Hello, everyone, and welcome to day 3 of Certified Ethical Hacker Technical Skills in 2 weeks with your instructor, Dean Bushmiller. As a reminder, check out that speaker bio icon on the bottom of your screen to learn about Dean. And before we begin class today, I'll point out some of those widgets on your screen that you may find useful. On the right-hand side of your screen, that's where you'll see the resources widget. You can download the slides or access links that you may need for class. And at the bottom of your screen, you'll see the Q&A widget. This is where you can enter your content-related questions for Dean to address during our session. We also have the group chat feature available, and you can type in any comments that you'd like to share with the whole group here to that group chat widget. And if you have any technical trouble, the first thing you should try is to refresh your browser. If that does not resolve the problem, let me know in the chat box or the Q&A, and I'll be happy to help you resolve that concern directly. And I do have to warn you, for those who are subject to regulated status, that the chat feature should not be used and that the audience may include customers, vendors, or competitors of you or your employer. And if you choose to take advantage of the interactive features available in this training, and we really hope that you will, you are responsible for any information that you choose to share. And with that, I will now turn it over to Dean. Dean, go ahead.
Thanks a lot, Heidi. And thank you all for being here. And thank you for the people who are being patient with me in testing their lab. Okay. I think the bug has been cleared, and I've gotten a couple of emails. I just got an email in, and I'll just say the person's initials, JH, has been working with me, and a couple other people have been working with me, and I appreciate that. Just to let you know, JH, you got to recopy your script because you have an old copy of the script from the GitHub. You have to refresh your browser on that one. I'm pretty sure that that's what that is, just for you. And if it works out for you, JH, then I know it's going to work for everybody else. So thank you for that. So we're on to day 3, and I want to pick up a couple of things. I want to let you know a couple of things. Sniffing, system hacking, and hijacking is what we're going to cover today. We have a couple of other things to set up for the day, and I do want to talk about the lab a little bit here. When you're inside of the lab and you're actually doing your copy, and I'm going to go there now. This has changed a couple of times, and you can tell how it's changed because you can look at the update time. So you can see, like, the README, that's this file that's listed right here, has updated 13 minutes ago according to my view of this particular lab. And so I also, by the way, in that README, if I make any changes there, if you were to look inside of the edits, you would see that the person like JH has gotten credit for that. So first off, this does not happen in a vacuum. I cannot do this alone. I do need your help. I don't like having you debug labs, but sometimes, unfortunately, from my position, even when I test, I can't tell until somebody rolls it out. So sorry about that, but I think we're in a good place, and I think I have JH's particular thing solved. The other thing, when you start your lab, you're going to start and stop your lab a bunch of times over the course of however long you're going to use this lab. Do not forget, one of the problems that we run into after it's set up is that the machines, you're going to turn all of the machines off at the end of your lab time, and you're going to turn them back on again. When you turn them on again, 2 things. It is just a little bit better if you turn on everything except for the guacamole, let them fully run and say running before you turn on guacamole. It makes it a little bit better for the connections between the machines, because the guacamole is trying to go ahead and get there. And if you try to hit the guacamole at the very beginning, there won't be any machines ready, so it'll fail a whole bunch of times in a row. It's not that big a deal, but your logs will look cruddy if you can get to your logs. So I start the guacamole a little bit later. Okay. You do not have permission access storage, AMI, you data version of the GitHub page. Okay, JH, I'm on it. So After class today, I won't be able to troubleshoot it in class. I'll try and do it at the breaks. But what I'll try to do is I'll try to spin up my other account on my other friend, and then I'll go back and forth and test it again, and I will report to you fully before you try again. So I don't want you to keep on trying. I do appreciate the work. The other thing that what happens is when you shut down all of these machines and you light them back up again, that IP address right there, that changes. So just realize, because we're using public IPs, the only one that can be accessed is the guacamole instance. The other ones can't be accessed unless you use your private key. There is a way to do that. We don't talk about it in class. But this IP address changes because I don't want you to incur lots of cost. So it flips off, and then it gets your new IP address and it flips back on again. And since they're public, then they change pretty radically. That's the first thing that changes quite often for people. The other thing that changes for people every once in a while, this is really rare. This happens to me probably once a month. I use Google Fiber. And Google Fiber doesn't want me to have a static IP address. They want to refresh that so that I don't start running servers from my house. There's ways around that, but it doesn't matter. But because of that, they change my IP address. That is why when you're going in, if you can't get access, if you go to your main page for guacamole, what you will find out is that sometimes you can't get access to that page, and it just won't tell you anything from there. You'll know that your machines are lit. You'll know that you're doing the right thing, but something has changed. So always check your IP address. Oh, I just lost my machine. Okay. So since your machine can change, be ready for it. The easier way to do not try to edit the rules. You can. If you're a cloud person, go ahead and edit your rules, and that's just fine. It's a lot easier to wipe out your lab and start over again. And remember, when you're wiping out your lab, what you're doing after you've gotten your images locally and copied them there, and this is in the recording, is you're going to the CloudFormation area and you're clicking on that, whatever that last one that has creation completed. And then what you're going to do is you're going to say, and don't do it now, you're going to say delete. That will delete all of your images, won't mess up with your copying. It'll delete all your images. It'll delete all your firewall rules. It'll delete all that stuff. It'll rip it all away. And then all you have is the old copies that you can use multiple times. So just be aware of those things. They cause lots of problems within the labs. This is all because I want you to have a lab that you get to keep that I don't manage. If you ever go into the O'Reilly and you use Catacodas or things like that, they manage all of that and they give you an interface right there and they take care of all those details. But if you turn off O'Reilly, or if you go somewhere else, or your subscription expires at O'Reilly, so let's say you change jobs or something like that, you still have these labs for yourself, and you can build a practice around using those labs and building them up. And then what I think you should do is learn a little bit of cloud enough to go ahead and build up your labs themselves. So that's it for labs discussion, although we will get into the actual labs themselves. Let's see. I'm going to look at my instances running right now. And my win, so this is the other thing that happens every once in a while. My Windows machine did stop. Now, that happened last time when we were doing the lab. It's okay that it stopped, but it only runs for sometimes, and this will be adjusted in future labs, it only runs for 1 hour, and then it shuts itself down because it doesn't have a license on it intentionally, because we don't want to steal from Microsoft, and you also don't want to have, you don't want to incur the licensing charge. So again, I've tried to make this as cheap as possible. That means that every once in a while you got to go in and go, okay, well, I'm going to start that instance right now, and it'll rerun. You're not always interacting with that instance, but those are all the problems that you can run into with the lab. Now you'll notice that I have finished a scan here, and I'm going to show you this scan because this will be important for our work together today. Now, the only thing that I don't like about this is I don't like the redraw on this, so I always change the shape of it. I type in services and it cleans it all up for me. And this is what we care about right now. This is the scan that we care about. And if you'll remember previously, here, let me do a redraw again. There you go. If you'll remember previously that you had a documentation sheet, and that documentation sheet should contain the IP addresses, the ports, the service that's running, and the version of the service that's running. So all of this documentation right here, it's a little tough to copy and paste, but you can copy and paste this into a sheet. Now remember, at the very beginning, I also said that when you're using that Google Sheet, you're only using it for lab purposes. You would never do this in the real world. So you have to figure out a way, and there are other tools that we don't talk about in this class for documentation to pull all this information out and keep it secure. You've got to work with that. For our labs, it doesn't have to be secure. You can look inside of here and you can see all this. And none of this stuff ever changes in the labs that I have unless I open up something new. I don't ever take something away from the lab. Let's see. So I got a couple of statements back from JH and AD. And again, I'll work on those at the break. Okay, that takes care of getting lab set up, tools that we're going to need for the class. You don't have to have a lab running in order to look at this and figure out how to think through this, but it helps. And so I will get that for us. Sniffing labs also don't require that you be running a lab machine, but you do have to be running Wireshark locally. And so now that's my next question to you all. With 32 people in the room, if you have the ability to install Wireshark, throw me an exclamation point. If you do not, just type in no Wireshark. But if you've got the ability to install Wireshark locally, please go ahead and do so. You would want this, and I'm not going to install my updates right now in the middle of class. You would want this, and then the files that I have available to you. Excellent, excellent, excellent. Okay. No Wireshark. Okay, SM, and for all those who don't have Wireshark, you can watch me. I introduced Wireshark today for 3 reasons. From a professional standpoint, it always comes down to the packet, so you might as well start looking at the packet now. That means that you have to have good skills in understanding that. Those packets all come from some sort of packet capturing device. I use Wireshark because it has an excellent display for us, not because it's a better packet capture tool, and there are all sorts of other tools out there. You can use, all sorts of different packet capturing tools out there. But I use this one because it conveys well in the classroom. By the way, when I'm doing this from a professional standpoint, I also don't use the Wireshark interface to capture things. I use the command line version of Wireshark, which is installed by default. It's called T-Shark. You should know how to run Wireshark, how to run T-Shark, know what the PCAP tools are that go in to make that work, and the installs that make the Wireshark work. On a Windows machine, we do not need to do capturing in promiscuous mode for the class. In the real world, when you try to do any kind of promiscuous mode captures, whether it's in VirtualBox, VMware, the live machine, the base operating system, something is going to stop you from doing that. You have to be aware of those capture issues. That's for the newly initiated when it comes to Wireshark. There will always be something in your way because they don't want you to capture packets promiscuously. That's just how it is. So that's the professional side of it. The business side, the exam side of things, it is fair to say that you can answer somewhere between 10 and 15 questions on your exam by knowing how to do the exercises that we start doing in this classroom. 10 to 15 questions on your exam. That's a lot out of what, 90 questions? That's, that's a nice big chunk. That's 10% of your exam with one tool. Now, that's not to say that that gives you all of your different sniffing capabilities, and we're going to talk beyond Wireshark, but all the lessons that I give you in this class, I'm going to share those with you, show you how they work. We're going to do a couple of them in class so that you can practice, and you can do them after class and send me questions back. I'll show you how to do all of that after class is over with, so that you can work with these and give me the answers to the labs there. You will see that I have opened up all the lab captures here for myself. And if I didn't, then what I would have to do is I'd have to go to my filer. And for you all, what you would have done is you would have said, oh, here's my lab. Oh, no, that's not my lab. We want to go to desktop, documents, desktop. CEH. Now you'll notice that I have the CEH 2-day and the CEH 4-day. That's because I have two different classes running. But if you go and grab the GitHub and pull the whole thing down locally, you'll get both. Okay. Inside of there, one of the things that you would get would be the lab captures, these PCAPs right here. You'll notice that they're numbered by day. Just do them in order. That's all you have to remember. Okay. There's a README on it. I'll explain all of that later on. But you can go into, and I'm going to click on day 3, and you'll see that there are 2 files in there. I know you can't read the files because they're really small. One of them is the text file that gives you the instructions for the lab and the questions and how to respond to me. And the other is the capture itself. So I'm just going to open up this text file just for a second here. It's going to give me some instructions. I'm going to show you those instructions in a different way. I can read my instructions, and sometimes it gives you hints and sometimes it doesn't. And the other part is I can open up the lab capture. Because I have Wireshark installed already, it knows, this is the Wireshark PCAP file. And so I can open it up, and when I double click on that, it drops it into my interface right away for me. The other thing that you need to do is rearrange the interfaces. We'll get to that. This will be on our own computers or AWS. TR, you can do this on your own computer in Wireshark. If you want to, when lab is running, you can actually do Wireshark labs inside of the Kaylee instance. So you don't have to do them locally. Like some people aren't allowed to install software locally. Therefore, they can't install Wireshark, so they can't see these things. There used to be a tool that you could use that would install nothing locally. It's called CloudShark. If you see any references in my labs to CloudShark, they started charging a lot of money for this, so I can't in good conscience go ahead and use that. But it used to be you could do them all, you could all do them all virtually, but you can't do that anymore. Okay. So that takes care of where we're going with Wireshark, and this is our first capture that comes up, which is Mod 3, Lab 3, Task 2. And I'll explain that numbering sequence for us later on. Okay. Next thing that I'm going to tell you about is all I want you to do is with your fake email account, well, not fake, with a non-business email account, I'd like you to fill in the form if you want my quizzer. So for the quizzer, I ask you to fill out a couple of details here. Your name can be a pseudonym. It does not have to be your real name. Your email address, you can use a temporary account, but I have to be able to send you back your credentials, your login, and your password for this. So I don't need your personal details. Keep them to yourself, but you fill them in here so that I have a way to send you your account separately. That's all you need to do there, and that'll lead us to, on the last day, at the very beginning of the last day, I'll give you a tour of the quizzer a little bit. It's a little different than most quizzers that you have out there because it's going to make you go through a couple of steps to get it all done. So if you're not on Menti right now, let me slide out of the way. You can jump into Menti here. Remember, that's also in the resources section. Try to open that up in a separate browser type. If you're using Chrome, then maybe open it up in Firefox or something like that. Okay. So everybody knows how to do that by now. We shouldn't have any problems there. I see that we have 35 people in the room, so I'll look for about 15 to 17 responses. I already know the answer to this question. Some people were lucky and they ran the lab beforehand. Yeah, those people who were able to run it beforehand and you aren't, it's not your fault. They did it early and got the old version of the lab. So I'm working on the lab for you. I know the answer to this question. Let's get tuned up to make sure that we have the that you've got your Mentimeter set up for yourself. Okay, so I can see that a couple people did their lab early, and for all those who don't, you can just send me a message today so that when I'm finished my testing, I can send you and say it's working. Don't struggle with your lab. Send me an email that says lab please. That's just the subject is lab please. Once I've tested it, once I know it worked with my separate account that I have a friend that will go and test, I will send back a response, lab working, please refresh your GitHub page. So, fine. Okay. Extras, labs after class. Now, I'm going to put this into the attendee chat. So, you do the labs in the wiki. Maybe we do some of them in class. Maybe you do some of them after class. But you need a set of robust labs that will get you up and running at the CEH level. These 3 sets right here, I've asked all these authors to go ahead and put these things here because remember, on the internet, things disappear. And these are the 3 best sets of Metasploit labs just past the CEH level. And I did this because I picked these so that they were just past the CEH level and just past the Pen Test Plus level, so that if you got your CEH or your Pen Test Plus and you did it with me and you did these 3 sets of labs, when you stepped into that first job and they started talking about Metasploit, you wouldn't panic, okay? So there's the 3 sets of labs that are for after class when your lab is running. Each one of these is geared toward the current lab setup that we have when it's running, those Windows machines, those Linux machines. It's designed for them. So just know that up front. Okay, that takes care of labs after class. You'll also notice in that exact same place, you'll see that there are the lab PCAP files, and I'm going to expand those, and you'll see the different days there over on the edge. I'll go into day 1-3. Now, there's the PCAP file. You can't do anything with that, but the nice thing is you can click on this, and it will give you the entire task for the PCAP file, so you can read it in the browser here. Don't do it with PDFs. Okay. You'll also notice in here that we have beginner, intermediate, and advanced for each one of these. In order to be prepared for your exam, you must do the beginner, intermediate, advanced for all the different days, be able to answer the questions. Since this class ends tomorrow at about 26 hours from now, 28 hours from now, it ends. How are you going to do this afterward? Okay, now here's the trick. If you were to take this piece right here, and that tells you what the PCAP file is. And you were to paste that into the subject line of a message with me. All labs must be done in AWS or maybe on VM. You can do them on VMs. I think they're better in AWS because it teaches you other skills. You can do them locally and they'll work just fine, but then you're supporting your own networking. If you post that into the subject line of a message to me, and you answer each one of these questions here, I will respond back to you, and I will tell you whether you got it right, whether you got it wrong, or what you missed. So you have to do your homework. You have to study through this, and you've got to work your way through each one of these. You've got to show me your work. But this is my answer. If you get a response to me that's just a short no, that means you didn't show me your math. You didn't show me your screenshots. You didn't show me your things. Okay. If you get a response from me and you're a little off, that's because I'm working with you. So that's the subject line right up there is just the file name, and then your answer down below it. I will respond to you the next time that I'm in email. You all float to the top of all of my emails. Okay, so that's taken care of a little bit there. I gave you the Quizzer sign up. I'm going to do the short tour tomorrow and not today. So now, before we go any further, do you have any questions from day 1 and day 2? I'm going to give a 60-second pause here, and then I'm going to read off questions here to help you. If you don't want to do them here, remember you can put them into the private Q&A at O'Reilly, or you can send me an email, and I'll put my email address in here just in case you've forgotten. I'm going to just be quiet for 60 seconds and let you think about your questions from day 1 and day 2. Okay, I had this question in email, and we're going to talk about this as where do we get readings? And that's a big deal for us. So I'm going to jump over and show you where you get readings. This is inside of the GitHub. Which tool we'll be using for pen testing? Oh, I'll answer that one too. Hang on a second. So if you're in the GitHub and you've downloaded the whole thing, inside of the folder called Today, there is a zip. This one is not encrypted. It's called CEH99 reading links. What does that look like? It looks like this. Now, what I did was I took all of the topics that were exam relevant. You'll notice on here, if you look up at the edge, there's no IoT, there's no cloud, not exam relevant. They can't test you on it well enough, okay? So when you're getting ready and you say, hey, am I ready for my exam? I'm going to open up scanning or sniffing because that's what we're doing today. Now, inside of sniffing, you'll see that I give you techniques. Can you explain, do you understand MAC attacks, DHCP, ARP poisoning, spoofing, and DNS poisoning? If you can't recite at gunpoint, should be on a note card. If you can't recite at gunpoint all the details of each one of those things, you're not ready for your exam. You go, well, Dean, what do I do next? I'm glad you asked. Inside the section down below it, it talks about resources. Now, I broke this down into two separate sections, O'Reilly and public. For O'Reilly, Wireshark for security professionals, when you click this link, if you're logged into O'Reilly, you'll get Wireshark for security professionals. Sometimes it's a reading, sometimes it's a video. Most of the time it is a reading. I want to stick to those readings here. So just to let you know, that one's right there for us and ready to go. Sometimes there's a public resource that is not as good. I always pick the O'Reilly resource that best solves the problem for CEH or Pentest Plus. But sometimes there are things that are publicly available that they're just better than O'Reilly because they're the original source for something. Like, for instance, if you want to learn about capture filters, display filters, or the ultimate reference for Wireshark, those are the top three. If you do not know the difference between capture filters and display filters and how to create them, you will not pass the exam. It's just flat out, because they will ask you questions about that, but also that's assumed knowledge for a lot of other questions. For extra practice and reviewing, I gave you two really cool places. There's one from Twitter, and this is the one that I like the most. This is called malwaretrafficanalysis.net. Remember, all these links are inside of that mind map. You'll go there to get them. Don't ask me for them in class. So here's the thing with malware traffic analysis. If you are a SOC analyst, that's a Security Operations Center analyst. There are a lot of those people that come to this class, and you want to learn how to do your job. You need captures, and you need captures that are specific to particular attacks that are out there. This is it. It's just the perfect place to get all of this. And so it gives you all the technical blog post, all those different things. And there is a password for every single file in here that you can pull down. Remember, these are PCAP files, so you can get into any of them you want to. I'm going to pop over to, let's see, non-technical. I think it's non-technical. Non-technical, oh no, it doesn't. It talks about the archives there. There is a page on here that talks about what the password is for each one of those files. I'm going to go to 2023 because that year is over with at this point. But like Darkgate, let's see, what was a big one last year? Iced botnet, you give it analysis on that. So this person is really, really talented at setting up these files, letting you do analysis on them, letting you work through the problems, and then revealing the solution to you so you can see these things. And so they've captured a lot of this stuff, which to me is just absolutely amazing. I really like this process, by the way. Form book day 26, they went through this entire thing here. That was a lot of work there that they did for us. So thank you to the malware traffic analysis junkie, whoever that person is. But remember, that's extra practice for reviewing. That's not what you have to do for your exam. So public material right there, O'Reilly material right there, and that was just for sniffing. And what I've done is I've set that up for everything that you care about for the exam. And so you can drill into each one of those components there and really understand. For enumeration, somebody wanted to talk about enumeration. The resources for enumeration at O'Reilly, they talk about service enumeration is one little tiny piece. Service enumeration is one little tiny piece there. The closest that we get to enumeration details, somebody talked about the DBIDS report in the emails, in emails prior to class. And they talked about that. And it does talk about enumerations in there, but it doesn't talk about how to do them. And see, that was what I was driving at. And the closest thing I got to was this set of enumeration right here. And this brings me to hacking articles. Now, this person, Raj Chandel, is just, he's a great guy. I mean, and I don't know anything about him. I don't know what he does personally, but he does a really good job about different SMB enumeration and all the different things that are there. He goes through very, very detailed SMB enumeration, but he only does it for that one. He doesn't do it for all the different protocols. So that's why you have my list that walks you through those things inside of my mind map. But a brilliant guy, and got really good labs there too, by the way. A lot of his labs work really well. It's a different setup than my set of labs. So there's all your readings. That's what you can go to and do. And remember, that's inside of one of the downloads when you downloaded the entire zip file for class. I don't think this one's password protected. Okay. I will talk about malware a little bit at the end of today's class, just for a brief moment to talk about the problems with malware. We're just going to dip our toe in there. When we come back from our break, we're going to talk about sniffing and why it's not just Wireshark. So I want you to take a 5-minute break. In theory, Heidi's going to be really happy for me because I've got my break slide working right now. It should pop up. It should mute me and say, okay, here you go. Here's your break. And it's a countdown timer for me. So run away, go play, 5 minutes, and then we'll continue from there. Welcome back from your break. And I got some really, oh, by the way, I wanted to say thank you for all the really kind words in your emails. I really appreciated them. And thank you for being patient with me while I work out the lab. And the other thing that I wanted to say is the skills for fishing are getting better. A couple of people have gone through some iterations and they've tried a couple of different things. And I'm watching it and I'm watching the responses there. All the things that you all try to do that don't work in there, if I feel that they're a good idea after this class is over with, like I really should have that word in there, or I should have a negative word inside of there, I'm going to take those words and I'm going to put them into the next version for the next class. So just know that fishing gets better and better as you go along, and you're also helping out other students in the future to do that. And if you were to fish something and get an email where you got a password, but you ran into that brick wall of multi-factor authentication, don't think that that was a failure. That password where you ran into that password may be good on other systems. So because this one has multi-factor authentication and you got a password, you fished that password and you got that given to you, by they responded to you, don't think that that's the end of that and that you can't use that again. So just know that those passwords that you get, collect all of that data and reuse that over and over and over again until you eventually get locked out of a system. Okay, with that, let's talk about sniffing here. From a conceptual standpoint, remember that the attacker is going to gather sensitive information and they want to figure out ways to do that. Since most networks today, even my little tiny network right here, is fully switched, the only thing that they get is that broadcast traffic, and you have to know it's all F's. Because the host really only listens for the broadcast, and they listen for their own MAC address, and that's pretty much it. This gets a lot more complicated when you layer on top of this a single port that's delivered to an office where you have a voice over IP phone that's got its own MAC addresses. Virtualization in any way, shape, or form also makes that really complicated. You get a lot more MAC addresses, and that's good for us as penetration testers. If you're testing an environment where virtualization or voice over IP is popular and end users have a single voice phone or maybe a soft phone, those kinds of things, if they have separate devices that need different MAC addresses, that's really good for you because that complicates the infrastructure protection mechanisms. So the security is a lot more difficult to maintain when you have multiple MAC addresses. So they kind of open things up. I'll talk about threats in a minute. Now, also, beyond the fact that the switching is going to muck things up for you, most of the traffic is encrypted in there. And if it's not encrypted, hey, that's great. Like if you could see passwords sent in clear text, and you would see that against a lot of these protocols right here. But, a lot of things have been encrypted these days. That control that's there, it may not be as secure as you think it is from an encryption standpoint. So that's kind of the good news. So what we want to do as an attacker is we want to force listening. We want packets to come to us. We want packets to be unencrypted in any way, shape, or form that we can. So now you've got to do a couple of extra steps in order to make this work out for yourself. You want to talk to that switching infrastructure. Before we go any further, if we're going to do ARP spoofing or MAC flooding, where do we need to be? That's my question. Where do we need to be in order to do ARP spoofing or MAC flooding? Physically, I want to know. I've talked about it and hinted about it. I want to see what you got. If you don't know, throw me question marks. Where do we physically need to be in order to achieve ARP spoofing or MAC flooding? I'll ask a different question. Yeah, there you go. You got it. Yeah, you need to be within that broadcast domain or on that layer 2 switch with them. Same subnet? That's a good indicator today because subnets and layer 2 network broadcast domains are close together. But I want to be really specific about this. You need to be on the same layer 2 network. And I want to say that, same layer 2 network, because that's a big deal. But maybe what we can do is we can overcome this. We could compromise a host. I don't think that you're going to compromise a computer, but an Android device, this is an Apple device, an Android mobile phone that is allowed to connect within that network, I think you can turn that into a sniffer pretty quickly, especially with a little bit older stuff out there. In theory, we could insert a tap to collect data as it flowed across the network, some form of a tap. That doesn't have to be expensive. We'll talk about that in the tools section. Now, what I want to do is I want to insert a tap and then also some sort of small small computer, because I want to tap that information. And the reason why I want to use LTE interface is because I don't want you to see that I'm capturing the traffic and then transmitting it back to myself. I want to go off that network and I want to go out there where you don't have any detection mechanisms. So an LTE interface or a phone interface that's not Wi-Fi enabled, that gets me those traffic, it gets me off of that network if I want to. So, okay, so how do we do this? Well, we could attack the device, and in the cases of like a mobile personal device, you're going to have to set up in your scope. You would ask the question, do you allow mobile device do you have mobile device management? Do you allow mobile device guests? Do you allow uncontrolled mobile device guests within your network? That would be the setup questions for that. And then you would say, when I'm doing this actual attack, I would like to insert a mobile device that is compromised into your wireless infrastructure, and tell them what you're going to do there, because you're not doing wireless hacking. What you're doing is you're doing an evildoer inside of the network, and so you have to have that set up. That means that you have to understand Android. That means that you have to be able to place that Android on a wireless access point, or at least, like put it inside of their location. What I tend to do with that when it's a mobile phone is if I say, this is your guest that's plugged in, I say, let me go ahead and put this into the senior security person's office, something with a locked door, and I plug it in. I plug it into not a port, but actually plug it in to a charging mechanism so that it always stays on, because you lose these pretty quickly. So just be thinking about that. Now, what I could do is, instead of attacking that device, I can attack the switch configuration. When we look at a switch, you either talk about switch port analyzer, which is called span, or port mirroring. They're the same thing. It's basically sucking all the packets across every single one of the ports and pulling it out one of those ports. Let's go back to enumeration for a second. If we can see that there are switches involved and they're speaking SNMP, we can reconfigure a particular switch port to mirror that data out to some other location. And so by having SNMP and the ability to reconfigure the switching infrastructure, we could gain access to data that we otherwise wouldn't have. So that's why we looked for enumeration, we looked for SNMP, we spent a lot of time dealing with it. Now, you could, in theory, attack the telephone network. First off, don't, okay? Because that's called wiretapping, telephone tapping. It's monitoring. It is almost globally a crime. There are some instances where it's not. In the United States, if you do wiretapping without a warrant, you're not a police officer, probably, if you're in this class. If you don't have a warrant, you can't do this. There are lots of people that are doing it. They're doing it against mobile device infrastructure. These are called These are software-defined radios that allow them to go against the mobile infrastructure. The only reason that they can do it is because they can move around and they don't get caught. If they get caught, boy, will you break out in handcuffs really quickly. So then we need the packet analysis skill, and we need to understand the protocols underneath of that. What do we do? When do we do this? Where are we? Well, in our reconnaissance, we could be listening. So we could just listen on that subnet if we're sitting inside that network, like you all said, okay? We could do scanning, and again, we could be listening there, or when we're maintaining access. I always say turn on a listener at all things. As soon as I attack a device, and then I go after another device, remember that's called pivoting, I go to another device inside of that network and I control that device. The first thing that I want to do is I want to see if I can turn it into a listener. Windows machines, Windows 11 and past, first off, it's really hard to do. Okay, I'll just tell you that right up front. On a Mac, an Apple machine, it's getting harder to do. But if you can do it, then you've got a toehold inside of that network listening to what's going on. If that's the case, then now we can listen to what's going on as far as that tool is concerned. And as we move from host to host to host, and we find that ability to listen, we're now gathering, we're doing more reconnaissance from a different point inside of that network. However, real world kicks in, and when we turn a machine into promiscuous mode, that sends a signal to a lot of intrusion detection, intrusion prevention systems. So what you get is you get a little listen, and if you're listening going along and all of a sudden it gets, like shut down and you get booted off of that machine, there's an IDS in place that's getting in your way. From a core term standpoint, I wanted to break this down into kind of the top 4 things, which is packet sniffing, hardware and software, and then switch versus shared. I wanted to take another bite at that apple. For packet sniffing, you have to be on that segment. Everybody's figured it out. The word is segment, if you wanted to. Layer 2 segment, if you wanted to. For software sniffing, that's that promiscuous mode. It listens. Windows machines don't allow you to do this. However, hardware sniffing, that is a physical copy of the electrical signal. Usually we call this a protocol analyzer at that point. The best one are the yellow ones, my opinion, called Fluke. They're not cheap. Don't forget, in a switched versus shared network, in a switched network, some device, whether it's the individual host or whether it's the actual switching device, actually maintains a list of MAC addresses. But it's pretty stupid. And that's the cool thing about it. Those what they call CAM tables, okay, they're dumb. They're dumb as a rock. And we'll get to that in a second. If you can get a hold of a hub, it's unlikely, that's all connections to all systems. We can listen to everything going on. I have found, like in the past couple of years, I haven't found any hubs, quite frankly, because you can get for your house, you can get like a 5 or a 4 port switch that is gig-E capable. That's 1 gigabit Ethernet capable for like $30. So there's no need to have hubs around. They just, they don't crop up at this point. Okay. In Wireshark, now this is really brief here for Wireshark. You must know how to do capture filters, display filters, and be able to follow the TCP stream. If you cannot do those at gunpoint, under duress, you will not pass. Okay, so now what we need to do is we need to think about how to do the techniques on this. There are really 4 basic techniques that are out there, and I add in the other 2 for completeness sake. That's kind of like the ultimate goal there, but you're going to either do MAC attacks, DHCP attacks, or ARP attacks. For MAC attacks, that content addressable memory table, the CAM table, is a specific size in memory. And so what we'll do is we'll go after that device with its memory, and what we'll use is something like MACov, and that's a really old tool out there. But let's think about what that tool does. It allows us to do interception and redirection. This is the first time that we talk about interception. Man in the middle, sorry, ladies. The technique is simple. We go to the switch port and we sniff against the MAC flooding. And so we do some MAC flooding that's happening. We set the tool up and it's doing that. And then we look at how long the entries last. That's what it's doing for us. It's kind of a reconnaissance tool that's out there. Defenders will try to do port security. Now, remember what we said at the beginning? That there could be multiple devices on a single physical switch port. And so port security is administratively burdensome and very expensive. Next level is DHCP attacks. That's dynamic host configuration protocol. That's how do we get IP addresses that aren't self-assigned on a network. You have to know from a Wireshark standpoint, the reply messages, all the different messages in the DORA process, that's discover, offer, request, and acknowledge. The last thing, what we can do is we can negatively acknowledge, and that breaks DHCP. So what we do is we go to the DHCP server on your network, and there can be 1 per segment if you're set up that way, or you can do what's called relay. And we go to that DHCP server and we take all of its IP addresses. The tool for doing this, been around for a really long time, built into Kaylee. It's called Ursina. And what it does is it just asks for all the DHCP IP addresses, and it takes them all. Now, that may not be detected, but an end user trying to get on the network who can't get an IP address because all your bases are theirs, they will complain to the help desk, and then you'll be found out. So therefore, what we do is we take a couple of other steps. We take all those IP addresses, we create our own rogue DHCP server. This is part of Ursina. And then we impersonate that DHCP server and hand out IP addresses. And we hand it a default gateway. Oh, the default gateway is me, where I'm listening. And I'll be happy to go ahead and terminate your TLS connection right here and all of those packets and let them flow through me, and then recreate that connection from me, re-encrypt it, and send it on its way out there. So Ursina is probably the best tool out there, the most underrated tool for capturing host on the network, or if you can't capture the host, at least convince it to come to you to send all the traffic through you. You've got to be on that network. You've got to be available there, but that could be a pretty small device. The defense against this is to configure port security and what's called DHCP snooping. That is not that administratively burdensome, and SOC analysts will pick up on that, and they will set those things up if they don't have them in place. So usually you come in, you do 1 DHCP starvation attack in your penetration test because you're smart enough to do it, and the next person through the door that tries to do it, it doesn't work because they turn on those controls. Next level is ARP poisoning. What you have to remember about this file, this list of all the MAC addresses to IP addresses in any one of the CAM tables, or even the local host has this file. The rule is last write wins. There's a tool called ARP spoofing, and what that will allow you to do is control that particular victim's ARP cache. So you can say, even though DHCP handed an IP address to let's say Heidi here, and she's got that. What I can do is I can go in at layer 2 and I can say that layer 2 address that's attached to this IP address, that's me. And so I'm here and I'm taking this MAC address, a different MAC address, same IP address. And therefore what we've done is we've knocked Heidi off the network. Now remember, she's going to kick back in and say, no, 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 this is my address. So what would be a good idea, a separate technique inside of here is when I go to Heidi and I steal her stuff, I steal her IP address with a different MAC address, the DHCP server is not going to look at that. My goal really is to either pick on Heidi because she's not there, she's gone to lunch, or knock her offline so that she can't get back on. So every time she pops back up again, I knock her offline. This works really well with end users' workstations. What we're doing is we're doing a redirection, allows us to do man in the middle and redirecting host on the same segment. That's the problem. The technique is to either request a reply or reset host ARP cache. You can do that with the ARP spoofing tool. The defense against this is physical switch port control. Again, too costly, too administratively burdensome. Now, what people will do layering on top of this to kind of crush this and kick it away is to do a lot of VLAN architectures out there. And then what we need to do is we need to start attacking the VLAN infrastructure, and that can get pretty difficult to do depending on the setup that they have. This is an old attack. I just talk about it here for completeness sake. This is called ICMP Router Discovery Protocol. The tool is a rogue DHCP server, and it's passive sniffing. Here's kind of the key to this. I send a spoofed IRDP router advertisement message to that host, and I make it change its setup. The problem is that in most cases, there aren't any old hosts that do this, and the solution to it is this setup, which is called generic ICMP IRDP block disabled. You set that thing up, and then that takes care of it. Your DHCP servers usually have this built in. It would have to be a really old client. I think that this would work against like some older Android devices out there, really old, like 10, 15 years old. But remember, there's a lot of stuff hidden in the network closet that hasn't been changed for years because it's working. Don't screw it up. It's kind of the thought. That means that the IRDP host has to have it enabled. This is a DHCP setting, which we don't get to do. Now, normally when we talk about any kind of sniffing, we don't talk about DNS spoofing and poisoning. It's not a part of the normal conversation here, but we need to think about what is the ultimate goal of each one of the hosts. After the host connects and it has a MAC address and an IP address, the next thing that it's going to do is it's going to say, I'm going to go to, and so humor me here, type into the attendee chat, what do you think the most recurring non-local host that end users are going to go to on a regular basis? Give me a list of, name those websites that they would go to all the time in a standard business day. What do you think? Give you about 60 seconds here. We will be breaking pretty quickly, probably next 5 minutes or so. Yep, they're going to go to Google or the alternative DuckDuckGo. Sure. Anything else? Weather.com, ESPN. Okay, now the company website, maybe, and I would like it if they did that. Like if they have an intranet, then yeah, I'd go for that. And that would be specific. They go to a Yahoo, they go to a Twitter, they go to Facebook. They're going to go to some of those places. Okay. Today, very good, CT. They're going to go to OpenAI. Very good. Okay. So we couldn't control the client, but we know where the client is going to go. What we do is we substitute the IP address either of the name server or the client's local information. We convince the client to go to the wrong place. We convince the client that we are the DNS server. We answer the DNS request before the DNS server can do it. See all the different ways that we can do that? Now, we can do this against the DNS servers, which they all have flaws in them. This only works on flawed servers, not all servers. But here's the key. If you go into Metasploit and you look up DNS attacks that are out there, there's almost 1,800 attacks out there against DNS. So it doesn't get talked about, but this is what we're going to go after. We're going to go after DNS servers, DNS clients, DNS caching. We're going to go after all of those different places because all we want to do is falsely resolve the DNS. This could be the victim's own cache, its own DNS server, the DNS server itself that's sitting on that network. You know, we can go at all those different places. Now, the standard tools to do this that take away a lot of the Metasploit 1788 is to patch. The better way to go that most people aren't doing today is something like Umbrella. OpenDNS, let's see, AOL, thank you very much, DNS. OpenDNS used to be a separate service that was out there. Cisco bought them and is changing them over to a service that they offer, which is Umbrella. And here's what they do. For the DNS servers, they lock it in pretty specifically for those clients. And they say, we'll do all the resolution for you. So that's one way to do it. But again, I could beat them to the punch in a lot of cases. So then our next level here is DNS over HTTPS. Well, it's actually over HTTP, and that leads us to DNS over TLS. This is happening more often these days. I've been using it on and off for the past 6 or 7 years, and I find that it is clunky. Why is that important to you? Because if it's clunky, if it's brittle, if it doesn't work really well, then clients are going to go, turn that thing off and let's go ahead and go back to DNS. So the enterprise requirement is that we do DNS over TLS. And the reality is that end users don't pay any attention to that. And they usually, you know, it's like when we go to look for the password and it's sitting on the bottom of the keyboard, they've short circuited, they have a really long password, but everybody knows it because all they have to do is they just look on the bottom of the keyboard and it's right there. Well, same thing, they're using a DNS server that they shouldn't be using, and we know that they're going to do that. DNS is UDP, which is usually faster. Right, there you go. That's why it's clunky, AD. You've got it. Yeah, I didn't want to get into the technical details, but you've got it. So the problem that we're running into is that the end user is going to say, that's a great idea, but I don't care. I want to go ahead and be faster about how I'm doing things, and that's when we take advantage. Remember, it's all about the user implementation about this. It's all about the administrative implementation and finding those things where people are doing things like putting their passwords on the bottom of their keyboards, or they're using a rogue DNS server. And so that's really what it comes down to. Separately, there is DNS end user phishing. This is, let's see. So the site that you would go to is, that doesn't seem reasonable, but that seems reasonable, right? I mean, we're not talking about and when you look at those two things, the last two entries that I put into the attendee chat, plausible, right? So in our phishing attack, if we can point them to another DNS name, we're in a good space, right? If we control that DNS name. By the way, if you try to go ahead and buy the Google with 2 zeros domain name, or a lot of other domain names that are really, really high profile, like Fortune, Global 1000, Fortune 500 type companies, they have a whole host of domain squatting, typo squatting kind of things where they've looked for that. And when they find a new one, you get a cease and desist order pretty quickly. I actually did this about 6 years ago. I tried to get it was called the CiscoStudySite.com. And I registered the domain, and within 3 days, I got registered mail that said, you're not allowed to use that name. And they knocked me off of that. So you think about the typo squatting, the tool that you use is either DNS Twist or DNS Chef. And what they will do is they will create convincing, fully qualified domain names. And they're not going to do it with just one record. They're going to do it with multiple records here. Now, the interesting thing about this is the defense against DNS Twist is actually the tool using DNS Twist. So you can set up, from a defender standpoint, DNS Twist on your network to look at all those different possible domain typo squatting. You get all of those records locally, and what you do is you null route them. So you point to 127.0.0.1, and you put that into a name cache locally. If I was doing DNS Twist for my company and I was running it, I would do exactly what TG said. I would do DNS Twist against my own company and make sure that I locked in all of those domain names there. I will tell you that most people aren't, and this works. If you're the first one through the door, the typo squatting works really, really well. There's a trick to this, though, and that is that you need to register those domains so that they're not registered last week. Usually in my penetration test, I ask my clients to set up 6 months in advance. I ask them to give me a $100, it's not a retainer, but it's a $100 deposit. It's non-refundable deposit from the time that we agree on this to the time that we do the actual attack. And I like it to be really far in advance. And what I do with that $100 is I go out and I run DNS Twist against their corporate domain name after they've given me a contract. I run it against their corporate domain name or any variations of their intranet servers that they have, or extranet servers. I run the variations on those second level domains, and I buy all those domain names just for this test. But I do it so far in advance that if they have any intrusion detection or intrusion prevention systems that are looking for this, like how old is that domain name, and they're just looking at how old the domain name is, I'll pass that barrier. And that gets into a whole nother level of stuff. Okay, we're almost done here. We're going to take another break in just a second. From a testing implementation standpoint, sniffing is all the time. Packets require decryption. The tool is Wireshark, and you've got to get good at data analysis. That's you. There is a tool that you might want to look at called DNS sleuthing. It's not an exam tool. It's a professional tool that's out there. From a control standpoint, they're going to put in some sort of port-based network access control, VLANs, those kinds of things, the VLAN authentication. There's not much you can do about that unless you're actually attacking that infrastructure itself. That's an entirely separate topic. They're going to put encryption. They're going to restrict physical access. They're going to put detection mechanisms in place. When you use one of those ARPing tools, those layer 2 tools, they're very, very noisy. And so as long as the IDS is sniffing that segment, it'll see it. But remember, most of the time, the IDS isn't sniffing end user segments. It's sniffing, IDS and IPS are sniffing server segments, and they're protecting servers. So you might be able to get away with it. Now, here's a cool thing from a defender standpoint. Nmap scripting engine allows you to check the local Ethernet card and see if it's in promiscuous mode. It's a pretty simple test that's out there that a lot of defenders are putting in place. So when you go to attack that device and turn this into a sniffer on their network, they're running Nmap on a regular basis against all of the devices on their network, and they're saying, oh, this one is in promiscuous mode, and that creates a seek and destroy mission for them. For DNS poisoning, they're going to resolve locally, they're going to block external, and they're going to configure their firewall to restrict external DNS lookups. For the DNS servers, they're going to use Umbrella. When you find Umbrella out there, you have to be very careful with your phishing attacks. Okay. Now, when we come back, I want to talk about, just briefly, the sniffing tools out there, a couple of professional setups that we're going to do. After we do that, we're going to do the first wireless lab. It's only going to take a minute or two for us to do. So what I'd like you to do is I'd like you to turn on Wireshark now and make sure you have your captures locally. You should have done that. And we'll come back from the break. So we're going to take 5 minutes. Run away, go play just for 5 minutes. Get your favorite beverage at this time of the day. With that, I am mute for the break. Welcome back from your break. So I wanted to talk about snipping tools a little bit here. First off, from an exam standpoint, if you're going to do any of the spoofing work, you have to have a client-server communication going back and forth. With a little bit of work, you can switch between the Metasploit clients that are out there, but I wouldn't do that. I wouldn't go back and forth between, you know, the Windows victim and the Linux victim, because then you got to log into those machines, and that's kind of a pain in the butt. So I just want to let you know that you can do that, and that is important when it comes to hijacking, but you have to have client-server communication going on. You can pretend to be the client in most cases, but you have to realize that, am I going to be able to do this in the real world? So for your lab purposes, it's fine that you're the client against that server. You know, Kaylee is the client and the server is the server. That's fine. And then you intercepting your own traffic. But real world, that kind of breaks. From an attacker standpoint, you can use, for testing for Wireshark, you can use Windows. I try to discourage this unless you're just looking at packets that are out there. Now, from an exam standpoint, what I did was I talked about a couple of different tools that are out there. Wireshark, I got into the deep details of it here. There are a couple of other tools that you need to know about. I want to talk about, well, TMAC and SMAC, they're actually the same tool. It's just, can you find a copy of one or the other? So they're almost exactly the same. So now, your CNI, I think, is the best tool in the list for actually enabling spoofing. So if you had to practice with two tools, it would be Wireshark and your CNI. Now, as a certified EC Council instructor, by the way, I'm on the outs from them. They don't like it because I teach a bunch of different ways and I don't use their courseware. But I guess they're okay with it. They keep on inviting me to all the different versions of the courseware that's out there. This was not just me. This was all of the instructors across the board said, can we stop using Cain and Abel? They asked questions about Cain and Abel. Can we stop using Cain and Abel because the tool's not supported and it's compromised? A lot of times when you go to look for copies or versions of Cain and Abel, and it only runs on Windows. So it only runs on Windows. It's been compromised. It's not supported. And usually what you do is you get bad versions of it. So what I did in this case was I said, okay, you got to spend time on this tool. If you're going to download it from the Wayback Machine, do it there, but be careful because it's not supported anymore. And David B. talks about this very thing. If you are going to download from another location that's not that, start learning how to use VirusTotal. Take that image before you install it on your machine and upload that, or an MD5 hash, or yeah, you can do an MD5 hash still with VirusTotal. Upload that and it will tell you whether there's known viruses within that particular instance. So I don't have a Windows machine in my setup. I don't strongly urge you not to go ahead and use a Windows machine. If you're going to, this needs to be in a really isolated lab, and check out your individual versions there. So now that's the exam side of things. I want to talk about the professional side of things as far as tools is concerned. First off, for Wireshark, you have to learn what's called TLS termination inspection. So that's the link to it in Wireshark. They talk about it. You should be able to do this not for the exam, but for the real world. You should be able to do this on Windows, Linux, and Mac. The hardest one of all to do this on is a Mac machine, to do the TLS termination. It's relatively straightforward on Nix, which is good. We do it inside of Kaylee and we take care of it. So then we talk about Wireshark, knowing about TCP dump, and then I want to talk about professional tools for tapping. So you might want power over Ethernet pass-through at the carrier grade. So gig E, 10 gig E, that might be necessary. And so you can buy a tool like this one. You'll notice this is called Shark Tap, but I just give you an instance of it here. The new Shark Taps that are coming out are 10 gig. The reason why these are great is because they don't need power separately, as long as power over Ethernet is being passed through them. You're pulling off a separate set of segments here, and these things are really bulletproof for the enterprise. These are also used in a lot of IDS infrastructures to pass data through. What you could do is you could do passive termination, which I do, and you can get this. This is called a LAN throwing star. And you'll see that you can see the 2 ports because it's, that 3/4 view there, but there are 2 ports on the other side of this so that you can connect up 2 devices. In my video, I show you exactly how to do that part. Separately from that, if you're going to be in a physical environment and you need to make things work well for yourself, you need to be able to do termination, crimping, and testing. And so you're going to need a tool to actually do that for you. I picked one out of a random set. The reason why I like the True Crimper is because of the, on the side of it, here, we'll zoom in a little bit here. On the side of it, it has the wiring diagram, and I always have to look up the wiring diagram for how to set things up. It gives a great pressure bar. It gives you a great crimp. You can drop the head inside of it, and it works really well. So I just thought it was a cool tool. There's about 6 or 7 different tools that are like this. If you're going to do any kind of physical penetration testing, you must be able to put an Ethernet head on a wire. You have to be able to practice that at all different levels. Also remember that now what we're getting into at Cat 6E, the wires are very, very fragile and brittle, so you need to be practicing that set of techniques against this. It's the new thin wire that's coming out there. It's much more difficult to do. I'll just tell you that right now. Okay, for supporting information for learning Wireshark, I gave you Chappelle University. It's outside. It's the best, fastest, most complete. Laurel Chappelle is the queen of Wireshark, without a doubt. She's the best at it. If you're going to do this long term, I think it's 46 labs. It's a perfect book. So I really do love that book for Wireshark long term. And then for network and protocol based attacks, O'Reilly has got an incredible book, Attacking Network Protocols. Notice it doesn't say Wireshark in it. So that's the thing that you're looking for, is you're looking for, where's Wireshark? Well, you want to learn this. This is about attacking the different protocols and working with the protocols. Gives you a deeper understanding from an attacker standpoint. So I find that that's pretty good. Now, by the way, that book is not in my other list of books. This is the updated version of that. So that is sniffing. And now I'd like you to open up Wireshark, if you will. And so I'm going to go to my version of Wireshark. I would like you to open up the PCAP file, mod 3, lab 3 task. That's 332. So that's on day 3. And that is 332. We're going to look inside of this PCAP file here. Let's see if I can boost this up so that you can see what's going on. Now, this is the most basic lab. Let's see. I think that's readable on your side. Okay. So 332, and here's the capture that's set up. Now what I did was I changed a couple of the windows. You'll notice that my split window for north and south is really small. What you want to do is you want to get used to dragging this up, so when you find a packet that you're interested in, you can drag it up and look at the details of it here What you don't see, I'm going to move out of the way for a second, is you don't see the hex window down here where my finger is. That hex window is really small. I never get rid of it because I have to look at it every once in a while, but that hex window becomes really important probably once in your life. And you have to remember that it's there. It's the beat your head against the wall for say 15 or 20 minutes, and then you go, oh, I need to look at the hex. And that's so rare that that happens. What's cool about that is if you're looking in the hex pane, that breaks into two sections. If it's a clear text password, you'll be able to read the clear text password, or de-encrypt it if you've done it correctly. You'll be able to read that password inside of that interface right there. It's really rare, but it happens. So now your first challenge is, what indicator in the default view color of this capture tells you something is wrong? Now, this is called the default coloring rules. So if you're an advanced person and you've turned off the default coloring rules, this won't be available to you. But I want you to look at this interface, and I want you to look at what's going on, and I want you to think about coloring and how can you tell something has gone wrong here? What's the indicator? You got about 60 seconds. Oh, throw me an exclamation point if you've got Wireshark up and the capture in it. CT figured it out right away. Now you notice I didn't hover over top of the red. And what I'll do right now is, so if we look right here, see where my finger is, you'll see there's a whole bunch of red in there. Red, bad. How's that? Okay. And so I'm going to just click in the middle of some of this red and see what it looks like. And I can move my mouse pointer there and click in the red, and you'll notice that it all turns red. I, on purpose, didn't lay into the red section because this kind of gives it away right away. So something is wrong with these packets based on the default coloring rules. What is it that's wrong with these packets? You'd have to go in and actually investigate it. Now, I'll tell you something's not right about this. And notice the communication. It's going from one host. Source is over there, 10, 10, 10, 16. Destination is here, quad 10. When I look at this host, and I'm going to click on this random one down here, this packet right here. Once I go into that section, it says something's wrong. Highlights it in yellow. And it's the problem is that you can see it in yellow, that it's in the same packet, it's doing a reset and an ACK. If you don't know your TCP and you don't know all your different flags, you're not going to get this right. You're not going to understand this. So even when they show you this, even when they might lay it out like this for you, even though it's highlighted, you have to know that you should not be setting a reset and an ACK in the same packet. It's not reasonable. All the other things are correct with it. It's just multiple flags of certain combinations aren't allowed. That's the level that you need to know you're networking at. So CT got it right away. Let's look at the next question. CT, you've done a good job answering that one. You don't get to answer the next one. This is the intermediate. Change your column display to add a destination port. Change your column display to add a destination port. And I spelled there wrong. Now, I tell you how to do that. I pointed to Palo Alto's networking on how to actually do the column display. And if you don't know how to do that, you can go there. But you can answer the question without changing your column display if you know a lot about networking. The question is, why are there packets without ports? Why are there packets without ports? Like this packet right here. AD's got it. ICMP does not use ports. We don't have them yet. Right. ICMP, ARP. Well, ARP is actually ICMP. Yeah, that's going back and forth. Okay, but you get the idea that there's no port yet. We haven't established that. There are rudimentary protocols that have no function within them. Now, timeout. For everybody who didn't get it like AD and CT did, that's okay. I've given you lots of hints here, and what I want you to be able to do after you're finished today is I want you to be able to have the ability to communicate with me. And as I said at the very beginning, that the message that you're going to send to Dean, the subject line is just going to be the name of the PCAP file. If you do that, what happens, and I only have it for my PCAP files, it's not the .pcap, PCAP-ng extension, it's each one of those. I've got it set up so that that line, and I think I've got 14 of them or 10 of them, and I've got that line set up so that when that happens, all those requests for support and answering those questions, they all go into a separate box, and I look at them. You will be third on my list of emails that I answer on a regular basis. I have I'm a virtual CISO, so all my virtual CISO messages, they all get answered first. Like right after class today, I'll be answering messages. Then the next level is my couple of business partners like O'Reilly. Anything that comes from O'Reilly gets sorted second. Third on my list is all the packet captures. Then I have a fourth and a fifth. It doesn't matter. So you can get answers from me, and I'm happy to help you with it, but you have to format it correctly. Okay, last one. You are building, you are using Nmap to scan for SMB weaknesses. I want you to build a filter for all server message block ports to show at one time. So you have to know how your filtering works. You have to be able to put the filter in the right place. I'm going to show you in a second. And I will tell you that SMB2 as a filter will not work. So what you have to know is you have to know how to do a filter, a display filter, and you have to know how to combine expressions. So what I'd like you to do on your side of the internet right now to get set up for this is I would like you to copy this piece of information and then search for it. I'm just going to open up search with Google, and it's going to come to this. I'm not going to click on building a display filter. I'm just going to leave that there. I'm going to give you 2 minutes. Here's the trick. Your display filter, don't put it in the attendee chat. Put it over in the Q&A so that other people don't see your display filter. So don't type into the attendee chat with everybody else because you'll give it away to everybody else and they'll have to, I want them to look it up themselves. Put it into the Q&A, post it there. I'll look at it. So I'm going to give you 2 minutes to figure this out. I'm going to be mute just for 2 minutes. 30 seconds left. Now, some people have given me answers that are using Nmap. It's perfectly acceptable real world. This is a perfect example of the exam questions. Build a filter for all server message block ports to show at once. What it doesn't say is in Wireshark. I don't put that there. So you're kind of left to your own devices. Am I using Nmap to do this, or am I using Wireshark? And so if they show you a Wireshark interface as a hint, they don't want you to use Nmap. You're scanning for Nmap weaknesses. You want to filter for that at this level here. The problem is server message block runs over multiple ports. And some people have figured that out. There's multiple ports that you can do. But what I'm going to do is I'm going to show you simply the norm. So I'm going to type in SMB. Now look at where I'm typing that. That's up at the top line. It's that thin white bar there. So I'm typing in SMB. Now, a couple of things happen. First off, it lights up in green. That means that the current filter is valid and you will see packets. So if I type SMX, it lights up red. In other words, invalid. I type in SMB, valid. Now, what you would be tempted to do is something like SMB2 and SMB. Now, I'm going to key that in right now. Let's see, SMB. I have a valid filter, but there are no packets that are both. Or, now I see SMB2, SMB, and I also see browser. Are you using and? Are you using or? And then the other operators that were cropping up were the double equals. If you were to use double equals up there, what would happen is that is specific. Okay. So somebody also wrote SIP contains SMB in quotes. That may or may not work, but that's only going to be for your SIP. But what I wanted SMB, SMB2, and the other things that are out there. Now, watch when I type in just SMB without the 2. Notice the SMB2s are in there. So now I'm just going to type in SMB. Notice that the SMB2s disappear. I want to see all network traffic. Now, you'll see 138, 139, 145. But now I'm going to go back to that filter again. SMB2 and let me see, or SMB. So now what I do is I get both sides of the conversation here between this. Notice this is going out 10 in 16. The next one is coming from 16 to 10. I'm seeing both sides of the conversation there without having to be specific about the IP address. Now, by the way, you could, since there's only 2 hosts in this, 10 and 16 in this, it's pretty easy to go ahead and do that. Anybody know what it looks like in the real world when you're doing this packet capture? How many IP addresses, how many protocols do you normally see? Anybody want to take a guess? We're about to go to our next break in just a minute or two here. So I will tell you, if you look down at the bottom here, right there, and I know it's a squintathon on my screen, but look at it on your screen. It says how many packets are in this total capture and how many are actually displayed. So real world, hundreds a second. Yeah, and AD, sometimes it's thousands or tens of thousands per second. And so what you do is you capture and then you review later on. By the way, don't try to capture inside of this interface and update as you go. Don't do that, because first off, you'll get a memory problem with your machine. So what you do is you do T-Shark captures, command line version of that, and it'll just flow them into a buffer. And then when you're finished, you stop the capture and you look at it. You can also set up T-Shark to carve off chunks of packets so that you can review them and you can stitch them back together, or you can separate them out. Those are all skills that you learn in Wireshark, not here. But in this case, what we want to do is we wanted to learn how to use the display filter of Wireshark, and we wanted to get multiple different packets that we were concerned with. So I hope that helps you to start this. Now, again, when we're finished today, whichever ones we get to, that's great. Whatever ones we don't get to, you know how to do the subject line now. You know how to answer these things. If you're struggling with it and you've gone through all the things, explain them to me. What's going to happen when you send it to me, I'm going to open up. This machine that you see right here is the one that's already got all my packets on it. And I go in and I open up each one of the captures that you're talking about. And then I also have my own filters that I apply to it. So show me all your work so that I can see what you see, and I'll tell you where you went wrong. I might not give you the answer. I might say, yes, you're correct. No, you're wrong. And if I say no, then that means you haven't done your homework. But if I say you're wrong and think about this, I'm giving you the hint to get you there. I don't like giving away the answer in this. And so that's how you do the Wireshark labs with me. I don't think you see those anywhere else. That's why I do this, because I want to give you something that you can't find or do somewhere else. There are plenty of other labs like Laurel Chappelle's stuff. By the way, if you get a chance to go to what's called Shark Fest, she holds that every year. Well, COVID didn't happen, but Shark Fest. If you get a chance to go to Shark Fest and you're a Wireshark person, it's awesome, and you get to see her. She doesn't know me from anybody out there, but a lot of people bought a lot of books because I've recommended her. She's incredible. Okay. So that's sniffing tools. We've talked about the sniffing tools. We've talked about the labs for that. When we come back, let's go over here for a second. We did that. That's taken care of. Those were your packet captures. You could have clicked on them there to get to them. You can actually click on these links and it'll lead you to that location. Okay. We answered this question here. When we come back from our break, I want you to answer this question. Run away and go play just for 5 minutes. And when we come back, I want you to answer this question, and then we'll move on with our next section. So with that, I'm mute for the break. See you in 5 minutes. Welcome back from your break. I wanted to talk about this answer for a second. This seems like a reasonable answer. But if we go back to the enumeration section, and this is, do you know your ports and the relevant ports? You'd have to include 130, 135, 136, 137. I think you have to include the other ports that are in that list to make this work. So it'd be a multiple compound statements. It's a little bit easier to do the full protocol rather than the individual ports. If you're going to do the individual ports, you have to know all the ports that are listed in that. I think that's 135 through 139 and 445. It's a good way. I like this way because it's specific, but then you're going to have to make sure that you get each one of them in there to make that actually work. So I wanted to point that answer out there real quick before we come to this question. Without looking at the packets, there are some times when you understand how things are working. Notice that is Module 8, Lab 1, Task 3. So you could look at the packets if you wanted to. If you understand your protocol and the communication, you can answer this without Wireshark. But what I will say to you is you don't know which things they're going to ask about which protocols unless you do all of my different packet capture labs, beginner, intermediate, and advanced. So I will give you 30 seconds. This is a separate capture. I'm going to do it, but I want the answer in here. So go ahead and drop the answer in there. So it's 813. You can watch me do that on my side, but it still won't give you the answer. That person is close, but not correct. You see that I put the capture in there. I mean, the filter in there, I typed in DHCP. You can type in boot P. The answers that came back were quad 4 is all IP addresses. That's really close. Node doesn't have an IP there. That's what really I'm looking for. The first response is, this response is correct. Okay. Well, it's the special network, but all IP addresses would be quad 255. But the key to this is that the node doesn't have an IP address, so it's looking for a response, and who does it get a response from? Oh, sorry. And then this is the other way to say it. It's going to know specific address. Yeah, so it's it can't go to the broadcast address. It's got to go back to wherever it was. No IP address is really what it boils down to. So excellent, excellent work. Okay. If you're interested and you want to look up BootP or DHCP, those are different protocols. BootP was the older version. DHCP is the newer version. DHCP includes all the BootP information in it, but it is a different protocol. It does have a different, it's not port number. It has a different protocol ID. That's before port numbers ever exist. So you can look at those there. But I will tell you, everybody looks at DHCP. Everybody looks at DHCP, and everybody forgets, and this is why I bring this up for wikiwireshark.org/DHCP. Everybody forgets about Microsoft's APIPA, Automatic Private IP Addressing. Anybody know? Type into the attendee chat. Anybody know the starting octet for APIPA addresses? All it tells you is that your DHCP server is turned off. Anybody know the starting octet, the leftmost octet of an APIPA address? It's the 169 address, not 168 that I know of. Yeah, that means that you have a wire, that you have a, it'll work, and actually it just started happening for Macintosh before, up until a couple of updates ago, up until Sonoma, I think they didn't play the APIPA game. And so it's the 169 address. I just saw the other day, I was launching this host that you see right here, getting it reconfigured. I have multiple network cards in a single host. I'm on 3 different networks at the same time to make all my video stuff work. And I finally saw a 169 address inside of a Mac machine, but it used to be Windows exclusively. Yeah, well, here's the thing: is it was exclusively a Windows thing, and now it's not. It's all it tells me is that that your DHCP server is broken. that's what it tells me. It doesn't work. Your every single local device that you have inside of your network will pick up a 192 address, and so if I see a 169, that means my DHCP server is not working and I can't contact it. I'm on a weird net. And in my case, I have a network with a separate segment network that has no DHCP server on it by design. It's a storage network that gets that done for me. Okay. Now, with this one right here, write a filter to only display IPv4 packets. There are 2 possible ways to do that. And this gets into the not command. Anybody want to give this one a try? So I'm in 813. This is 813. So I'm going to try not IPv6. That will work. I also think the shorter version is correct. Yeah. Bang. Bang is the not symbol. You need to be able to know how to do the IPv4, which is your standard. But you'll notice that IPv4 doesn't work, right? IP works. but you want to know how to do the inverses. So you can just type in IP, that's fine. But you want to know how to do the inversions, which is not, and you can do, I think it's not, well, you did not IPv6. Okay, and that one will work also. Got to be careful with this one because there's a lot of different IPv6 protocols that are out there, but the bang is your friend. So you want to know how to do your filters and you want to know how to do them multiple ways. Sometimes you combine the nots and the positives together because you want to see certain things. I point out IPv6 because it's becoming more prevalent today. And that's, I have to, you have to include that to be a good professional. I'll do IPv6. And here with IPv6, I do get, let's see, bang. That would be not IP. I don't think that one would work. That would be not IP. You'd have to do IPv6 on it. If you look here inside of this packet capture that I have, you will see that there is IPv6 traffic in this capture, and you'll see the new MAC addresses that you have to be ready for. Anybody know, here's another question for you for the attendee chat. What does the double colon in the middle right here? So if we look at that one packet up at the top and you see double colon, does anybody know what that is or what that does? It's special within v6. Bang will not show TCP and UDP traffic. Let me look at that. Oh, it'll just show the IP traffic. Oh, I see. Let me do that. IP question mark. Let's see. Bang. IP. Oh, that doesn't work. I can't make that work on mine. There you go. AD got it. All zeros, shorthand for all zeros. Right. It's a whole bunch of zeros in the middle that are ignored. Good, good, good. Not question mark. Okay, got it, got it. Oh, because you were answering the question. So you were saying bang IP. Yeah, that'll take out some stuff there. Okay. All we wanted to learn from this one display filter was the use of the bang symbol and how does it work. You can also use the not, and that's fine. When you get into compound complex equations, you start using brackets, and that's not a lot of fun. So just be ready for that. Okay. So now you've seen a couple of the other possibilities here. If you didn't do them, it's okay. Now, I've got a couple more questions for you here. I'd rather do this kind of thing with you than do all lecture because you can watch my videos. So, what is the tool help for MacOf? Please don't cut and paste. Please type the command. Anybody remember where to go to get help on this command? let's see. I'll give you a little hint here. Kaylee. Okay, that's sad. Anybody get it? Gave it to you right there. Okay. So here was the trick with this. It's on a man page. So it is a Linux man page. You can do it that way. That's your hint. That's so man MacOf. If you want to. I don't know if the MacOf help will work. Yeah, it's a man page. And that's the thing. You've got to be ready to, that was the hint inside of the question was when you're going inside of the command line and you're doing those things, is it the dash? Is it the -H? In a lot of cases, I tell you to go to kaylee.org/tools, but MacOf doesn't show up there. Interestingly enough, MacOf is a really popular tool when you're doing the OCSP courses that are out there. Okay. Okay, where are we in our hacking process? This is a trick question. Which stage are we in right now when we're talking about sniffing? Is scanning the only stage we're in? I mean, somebody said recon here. Remember I said it was a trick question. Anybody else got it? The answer here is multiple stages. I'll take scanning or recon, that's fine, but it's multiple stages at this point. And so that's really what I wanted to get out of this one. Let's see, there's a comment here. Node doesn't have an IP. Oh, yeah, so somebody answered that question there. That's fine. Took care of it. Okay. For your exam, you must be able to look for a different tool or use a different tool, especially if you are going to do the practical I think they call it now they call it the master CEH. You must be able to use the tools that they give you. You must know how to swap tools. This is one section of your exam where they ask you a question and you want to use Nmap, and Nmap's not there. What's the other tool that's on this list that is a reasonable substitute for? In this case, TMAC, what is another tool that does the same thing? And I did mention it in the discussion. If you got nothing, throw me question marks. There's nothing wrong with that. But then that brings up putting it on a note card. Yep, it's the SMAC. So if you can't talk TMAC, you can talk SMAC. That's how I remembered it from my exam. So it is SMAC. Good. Okay, here's your exam level question. Why don't we do passive network sniffing generally? Why don't we do passive network sniffing? Because switches won't show you irrelevant traffic for your device. Much of it is encrypted. Both answers are true. Anybody else? Sniffing is real-time data capture. Yeah, I like that, the way you're thinking there. All I was looking for was encryption is your best thing. That's tops on your list, and then it's layer 2. Okay. Oh, I like that as an answer too. Promiscuous mode may be detected. Good. So that's the opposite way. That looks like it. Passive network sniffing. It's why don't we do passive network sniffing? So those are the inversions of that. But active network sniffing is not necessarily noisy, but it does turn your network card in a detectable mode. Okay. But generally what we're looking at here is the reason why we don't do passive network sniffing, we'd have to be on a hub to do it. Hubs don't exist. And so what you could say is because we are fully switched. And that's how you look at it. Now, by the way, today, I'm giving you open-ended questions for quizzes. When we go to tomorrow, I'm going to give you more exam traditional question with 4 options. But I want to let you know that I try to make these a little bit harder than the real exam. You should be able to get this one in about 30 seconds. Which layer is only useful in the local segment? And why not remotely? I want both answers. That's part of the answer. Layer 2 is not routed. That's really close to being exactly correct. Anybody else? That is the exact answer. Layer 2 headers change per router. Very good. They're stripped off. So if you were to look at this from a networking standpoint, you would see this host right here, and then you've got a router here, and then you've got a host right here. Let's say that we're going across that router. What happens is the layer 2 address plus the layer 3 address, and this is layer 2A, okay? And this is layer 3A address. When it gets to this router, what happens is this router appends B layer 2 and A layer 3 to this host to send it along to this host over here. So that layer 2 address right here is stripped off at the router, and that's the perfect answer there. That's very good. Oh. Keep on forgetting that my tool, this tool right here, which is my whiteboarding tool, kills my remote session. Okay, that layer 2 header is changed per route is the perfect answer there. The other ones are really close, but it gets changed at the routers themselves. That shows an understanding of routing and networking at the same time. So very good, very good. Okay, so now how hard was this section? Was it easy? Did you struggle? Did it make you want to cry the entire time? Where are you? Give me your votes. Now, you'll notice we had a half an hour of discussion on setup and labs and things like that. And I spent 2 hours on this section. Why? Because this is the place where lots of points can be gained and lost. This is the place that people struggle with the most in here, so I spent the most amount of time on it. The other 2 sections also, by the way, are easy to describe, easy to do. We have great labs on them. They're easy to do after class without me. But this is the place where you have all this weirdness that happens. If you are struggling with 50% of this, what I would say to you is Wireshark, the book on Wireshark that Laurel Chappelle talks about, is going to be your best friend because it goes into so many different details. If you had a few problems, what I would say is do the Wireshark labs and they'll be fine. Those people that struggled or wanted to cry most of the time, you really want to read the Laurel Chappelle book and work through those examples and then when you do my quiz questions for your exam, they'll be really easy. So that means that you're going to be taking an 8 to 16 hour detour there within this section. Now, here's the other strategy that you could take here is screw it, I don't know the packet. You could just go, I'm going to take a beating in this section and I'm going to know all the other stuff really, really well. You're at the beginning stages of these things, and this becomes so important later on that that I think it's a reasonable strategy when you're limited on time, but it causes problems later on for you. So that's what I want to let you know there. Okay, so now we get into section 6, system hacking, and we talk about Metasploit. So You could run screaming from the room. This is going to be a relatively short section as with the other section that's out there. We're going to, I think we should take a break here, just a 5-minute break. And when we come back, I'd like you to get into that mind map with me. These two other sections, system hacking and hijacking, they are going to be short. I've given them the time that they need within this plan here. But what I will say to you is if you ran screaming from the room at this moment in time because you had to go on to another appointment, do the labs that are sitting inside of here, right here. Do my labs for the wiki to start you off, but then do these labs right here and you're in a golden place when it comes to system hacking. And you don't need anybody else's labs. They're really strong to go through. There will be some overlap between each one of these labs, but that doesn't matter because you need the overlap practice. Otherwise, I would have cut it out of those things. So with that, what I want you to do is I want you to run away and go play just for 5 minutes. And when we come back, we're going to be jumping into the system hacking. Sorry, I got the wrong one up there. We're going to be jumping into this mind map and discussing here. With that, run away, go play. I'll see you in 5 minutes. Welcome back. We're going to do system hacking. And by the way, this is a hack. I don't know if you've ever heard of the AeroPress before or not, but this thing almost makes an espresso. Almost. It is, and it's $20 US. This will make a powerful cup of coffee for you. Mine's so worn now that it doesn't have any numbers on it anymore. But if you get a chance, the AeroPress is a really good tool. Okay. System hacking. So what we do is we take all those skills that we took before. Oh, AD is pretty stable. Yeah, I don't do it with. Actually, I've done it with a paper cup. I've rolled the dice and done it with a paper cup a couple times. Don't do that. So we're taking all those skills and we're putting them together. And remember, in this step, this is this potentially you could go to prison, and don't confuse prison and jail in this case. So you would have done footprinting. That's the reconnaissance term that EC Council makes you memorize. You would have done scanning. You would have gone and looked at, and you would have scanned, and you would have seen these hosts right here. Here, let me go to those hosts. Let's see. Oh, it knocked me out. Come on now. There you go. You would have scanned the host and you would have seen all of these real world. You would have seen multiple IP addresses with 1 or 2 ports open. You would not see this. If you saw this, remember, this would be a honeypot probably if it had this many ports open of all these different kinds of things that are out there. By the way, the RPCs at the bottom here, they mean nothing. They're fiction. They don't do you any good. You can't attack the remote procedure call process unless you're already on the box. So that's not really attacking it at that point. And so you've got a bunch of different hosts that are open at this point that you can work with. Going back over here, you've done the enumeration. So what I can't show you there is going into each one of those services and saying, what do you have? Remember, in the enumeration process, what we did was we tried default credentials. We tried credentials that we captured from our reconnaissance on the outside, like you did with expsec.us. We got some credentials there. We're going to go ahead and try them here against each one of those services. Remember that the credential that you use on the outside of this system that you used in that case was the full email address. You need to split off chunks of this, like user, like the before the email address, you might have like a C3PO, and you might chip off the @expsec.us. You might throw that piece away. You might try to log in as first name dot last name. Remember, they have a real first name dot last name that's separate from their email address. You might type in first name underscore last name. All those different variations would give you all the different possible user accounts that you would go after each one of those services, testing for each one of those passwords that you had captured on the inside. That means you have to be really organized about this. This is why I tell you to do documentation early on, because otherwise it gets muddled and it's like, okay, I forgot some stuff. So we do the enumeration against each one of the services. What will it give me? Default, no account, user account. What will it allow me to get a hold of? And do those enumerations get me to do anything else? Remember, vulnerability analysis isn't really penetration testing, but it's the thing that all of us do when we're very first getting started. So it's not vulnerability analysis. You would not have that level of detail except for, of course, the stuff that you got from Nmap. Now, prior to this, even in the enumeration, no law has been broken against any kind of corporate asset here. It has been broken. Notice it says corporate assets, governments and military, medical, those three, you're going to get in trouble. Okay. You can't do anything to those. You do anything with those, somebody will find a way to be angry with you and have a better attorney than you, and you will be in trouble. Okay, so now what are we doing? Here, our stimulus is true attack input. It's not looking at that and going, oh, that looks pretty bad. It's going, let me stick a finger in that thing. That's the true attack input. Our response now is control over the asset. Our response now may not be control over the asset and may be leaked confidential information. It's usually control, and then that comes to. Some of the people that I've worked with say, you can go ahead and go anywhere you want to non-destructively, and like their scope is this. Go anywhere you want to non-destructively. I want you to look up, like especially for research and development firms, I want you to find the super secret plans for the next version of our hardware, software, or whatever they're manufacturing at that point. We want you to find that information. As soon as you find it, as soon as you find file names of that type, we want you to stop the test, encrypt that data, return it back to us. And then we want you to, and like they'll even say, we want you to delete all process that was before that. And they'll make me wipe out everything at that point. So they want me specifically to find their really important, what they call them, keys to the kingdom. When we're in exploitation, that's where we are right now. This is the exploitation step. We are actually compromising the system vulnerabilities. It's not just enumeration. It's not saying, hey, what can you tell me about yourself? We're actually using those vulnerabilities against them. We're gaining access. Once we achieve access, it'll be a lower level. We want to escalate our privileges ultimately to the perfect level, which is system or root. And then we want to execute applications that will allow us to maintain and control that asset and exploit other assets. When we go from this machine to this machine and start controlling the second machine in this list, we are doing what's called pivoting in Metasploit. This is where we have to rethink all the things that we got here, all the knowledge that we got here led us to that other asset, but it might be that none of this information is any good on that next asset. We do not do pivoting from machine to machine in our labs, but that's what you do in the real world. What we do is we pivot from service to service in our labs. It's not really pivoting, because pivoting means going to another machine. But that's what the adversary does. They hop from machine to machine to machine. Are we covering our tracks? Okay, let's say we are. It depends. It depends on what the scope says. If we're covering our tracks, then what we're going to do is we're going to say there's this data that we want to get off of that machine. A lot of times there will be low-level controls in place. Data loss prevention is not a control against an adversary. It is a control against mistakes made by well-intentioned employees most of the time. It cannot protect your organization against me going in, stealing that stuff and pulling it off. Because when I pull that data off of those machines, I don't just pull it so that you can do a scan across that file. I will do either steganography that makes it look like it's normal communication coming outbound. I will do encryption on top of that, especially if I'm an evildoer, I'll do both steganography and encryption. Most of the time, I will use what's called the command and control channel to pull that data off of that machine. You won't have a DLP listening for that. Today, there are newer organizations that are doing, it's called ERD. They're saying that we detect for that command and control channel. Um, and people who are much smarter than me go, no. You may detect based upon the signature that is discussed in MITRE ATT&CK, but I don't ever use the true command and control channels that are discussed and detailed in MITRE ATT&CK. I use something that's an adjustment off of that. So we'll encrypt and do steganography. If you don't know what stego is, don't worry, we're going to cover it in a second. Am I going to remove evidence from logs? Is it in my scope of work? And be very clear about this. Say, look, are you going to be defending while I'm attacking at this point? And then do I have the right while you are defending to defend my actions within this network? And ask those questions. Be really clear about that up front. Because if you don't know, what happens is the person that's hiring you to do this, they don't know. And if they have an incident response team, you might even ask that question. Do you have an incident response team? How should I react to them? That might be the way to do it. But if they don't know that they have an incident response team, they might not have the authority to get you to do the penetration test. How about that? That would really suck. Now, especially any kind of checks that get cut for you. That's why I always, by the way, it's one of the reasons why, remember I told you about that deposit check, that non-refundable deposit check of $100? Because if an organization is willing to cut you and you say non-refundable deposit of $100 based on this scope of work, those people internally can't hide that from the accounting department. The accounting department is going to go, wait a minute, why? Why are we doing this? Hey, whoa, you don't have the authority for this. But if the accounting department cuts you a check for this thing and it's not some soft, smushy, nondescript reason for this $100, and my reason is always penetration test, vulnerability assessment, something like that. If they're allowing that check to go through at that point in time and that person doesn't have the authority, that's their problem, not mine. That's how I look at that. So I ask, how am I going to deal with this? From a core term standpoint, now we break this down. I want to be really clear about this. We break this exploitation process down here into these components just to make sure that we've got a clear understanding of what gaining access is. It's preying upon the flaws. Escalation of privilege, that's from low level privileges, guest, that kind of thing, all the way up to root. When we're executing the applications, and this is that place where we have to know, are we fighting defenders internally? Because if we're not, we may not need to install Trojans, backdoors, rootkits, and keyloggers. By the way, where we deploy most of this stuff is on the client side of things, is on the mobile device, is on the tablet in that environment. It's on the computer. It's not on the server. Very rarely do we install these things on servers unless we're doing this really heavy duty adversarial thing. One of the things that I've seen is on servers, they install backdoors into those systems, actually Trojans that are on those systems, so that when the local administrator goes to get onto that system to figure out what's going on, as soon as they log in at that point in time, it'll like waste the server, it'll blow the server up, and like it'll go ahead and start overwriting and like chewing on all the files that are inside of there. So that may be what the adversaries do, but we would never do that kind of thing. So our Trojan needs to say, it needs to have a pop-up screen on there that says, at this point, I could wreck your server because you've given me administrative privileges. It tests for all those conditions and says, if I was evil, I would really get you here. If I was evil, this is when I would do my ransomware attack because I've got escalated privileges that I'm using of yours on this server. And, you go poking around in there and double clicking on things. Low-level administrators do this all the time. What we want is, really, we want remote access to the system in other ways. So if we're doing that with a server, we may cross services, But since one server, one IP address, one port, maybe two, one for administrative side, since that's maybe three, since that's what we're looking at, those other system accesses, we would have to open those up. We would have to say, oh, you're just an SSH server. We're going to turn you into an FTP server at that point. So that would mean installing software or whatever software is available to me so that I can then go connect to other machines. A classic example of this on the server side of things is you're on this low-level server that doesn't have FTP, and you can see across the network that there's an FTP server over there. In other words, FTP is allowed inside for this organization. So you stand up an FTP service here and you talk to that FTP service over there, and that looks like reasonable, to the uninitiated, it looks like reasonable communication between two FTP clients? No, it's FTP service going back and forth. And this is where on that original machine you would store your loot. Hiding files. How we hide files is we make those files look like normal stuff. How we make them look like normal stuff is we use the concept of steganography. Steganography by itself only hides what that file looks like to the rest of the world. If Heidi and I are really good friends, and it turns out that Heidi and I are both cat people, okay? If that's the case, then we might have a shared interest, and we go to peoplewholikeCats.com and we post pictures. And Heidi goes, oh, that's a beautiful, I'm not a cat person, by the way, I'm a dog person. Oh, that's a beautiful cat. Okay, I've appreciated that cat picture. Let's take a picture of the cat posing in a little bit different way. Oh, that's a much prettier picture, you know, that kind of thing. You get the idea? Well, what it really is on this machine over here, what I've done is I've compromised this host. I've pulled information from your server. I've brought it right here. And then I sit on this machine and I take that data and I carve it down into little pieces and drop it inside of cat photos and post those cat photos. The organization allows us to use our machines, our end users' workstations, for both business purposes and for social media purposes. That's perfectly acceptable on our downtime, on our lunchtime. And so we'll allow that to occur. That allows me to create a channel of communication that I can shove other stuff into and send out there. But remember, steganography is not encryption. You have to do encryption separately from that. A really cool tool to do this with is something called CryptCat. It's not something from your exam, but it's something cool. For covering your tracks. So how do I clear my logs? How do I get the defenders to clear the logs? In covering the tracks, that's what we want to do. Make sure that you have really specific instructions for the administrators to back up and restore to those servers that you're going to be stepping on. If not, recognize that you could get blamed for the fact that they've got bad backup process in place. In the real world, what you want to study after this is over with, after you've gotten your CEH or your Pentest Plus, you want to study common attack patterns or attack. I have a set of videos on at O'Reilly on threats and vulnerabilities that you can look at both of those things, or you can come to I have a 2-hour attack class. I think it's 2 hours or 3 hours of a 2-hour attack class that I do. That's a MITRE attack. Okay, now the techniques here, I wanted to break them down into our majors that we're concerned with. You'll notice that covering tracks doesn't have much on it. I talk about exfiltration here, not because we do it in most cases, but because, quite frankly, they ask you a lot about it on the exam. Let's focus in on gaining access. So you're going to use their accounts from Recon. You're going to pick up your passwords if you want to. Go after your non-electronic attacks. You know about those these days. You've been taught in your user awareness training. Then you go to your active online attacks. That's going to be using default password guessing from previous stages that are out there. You tend to want to use dictionary attacks that are out there. Most of the tools out there will take a list of usernames and passwords. Remember, that's going to be a Cartesian result. If you've got 5 usernames and 5 passwords, most tools are going to take all those passwords and apply them to the first account, second account, third account, fourth, and fifth account. So there are going to be 25 attempts at that point. I would use a SecList, which is the one that I talked to you about. You can use SecList against your internal machines. The rules generally are, for my setups, the way I've got them working, if you're going to use any of the SecList out there, use something with 500 passwords or less. If you do anything past that, you could knock the machines offline, but also it's unnecessary because all those good passwords that you're guessing from, I took from those lists. I made sure that you didn't have to spend months on that. If you've decided to brute force, then you're going to use tools like Brutus on Windows, okay? WebBrute on Windows, THC Hydra. You're going to use THC Hydra. By the way, it's the one that I have in the lab. I think that THC, that's the hacker's choice, is kind of the best tool out there. Medusa sometimes, Ncrack sometimes. I use THC Hydra. It works really well for me. It works in most situations. I don't like to use THC Hydra with big lists. I like to use small lists that are out there. So I would use SecList to find my list, and I would use Hydra to pump those lists at those particular ports. In my second round, now once I'm on the machine, usually on the host level, it could be the server level, now I'll use Trojan spyware and keyloggers. If I got an end user account, remember my goal is escalation of privileges. If I got an end user account at the lower levels, then what I can do is I can keep on kicking that user off of that machine over and over and over again until they go, I got to call help desk. I got to call help desk. And so they log off, and who logs in next? Somebody with more privileges. And that's where that keylogger, spyware, or Trojans captures that information. And then I use that to, once they're gone and the machine's all settled down and it works just fine. We don't know what you were talking about here. But now what happens is the end users convince them to give me those credentials by accident. That the credentials there, I capture those and I use them against other machines, or I wait until the end user goes to lunch. In theory, we could do brute forcing. Well, we could do dictionary attacks against a host by passing the hashes to them. And the way we would do that is through rainbow table attacks. This is nothing more than a sorting algorithm of all the brute force passwords that we have out there. You should take the time to look at rainbow table attacks, understand what they are. I've given you the link to it there. It's almost past the exam, but I leave it here. And then understanding how passing the hash works, which is basically the encrypted password already. Now, in theory, you could crack databases of passwords. The problem is that in theory, it's easy to say and it's difficult to do. So pull a copy of the encrypted database, really hard to do. Lots of defense mechanisms around there. You could go after the SAM, you could go after Active Directory, or you could go after the shadow file. Now, I will tell you, I haven't had much success with these, and maybe it's because I don't have the skills in this area. I've heard a couple people do really well against this, but there's so many protection mechanisms around these, especially intrusion detection, intrusion prevention around this, that when you go after those files and do those things, you get booted off the system by much of the low-level automation that's out there. When we're talking about obtaining the password hashes in Windows, usually we want to focus our time, this is inside of Metasploit, on what's called LSAS injection. The tool that you would use would be Metasploit calling pwdump or fgdump. Or the best way to do it today now is hash dump in the Meterpreter. Meterpreter is a separate subsection of Metasploit that we walk through in those 3 sets of labs that I talked about. If there's really bad software out there, you might be able to extract the passwords from the registry. Have you ever seen that machine that's been upgraded and upgraded and upgraded from operating system to operating system, and they bought a really big beefy server and they don't want to wipe it out and start over again? They just keep on upgrading it. Well, in that case, if there's previous versions, those registry settings might not get cleared out. So you could go in and look at an old version of that software, get an old version of that password that will work in the current version. This is easy to say. You don't see this as much these days, but we're copying that stuff out. And usually we won't get the password in clear text. We'll get it in some sort of hash value that we extract. We take that hash value, and since we know what the hashing algorithm typically is, we would then take that to a rainbow table and it would tell us what the password is by just doing the sort by hash value, not by password name. Okay, we're on the box. We've gotten that level. We want to go all the way up. The two ways that we do this that I'm not going to talk about in this class, I do want you to, we'll talk about DLL hijacking, is DLL hijacking where we go onto a local machine and we're abusing the execution path of a Windows machine. We're abusing the path command when we're doing DLL hijacking, because local executables like Word, PowerPoint, and Excel also have local files that they would either call on or they'd go up into the operating system and pick them off. If that DLL or fake compromised copy that I own can be installed next to that machine, that executable like PowerPoint.exe, it won't go searching up the path to go find this thing. It'll just pick what's right there. And so DLL hijacking is wonderful. People are catching on to it in the major applications that are out there, but in the minor applications, we're not talking about Word, PowerPoint, Excel, PDF viewer, and those kinds of things. We're talking about local executables that were built by the company. Then we can do DLL hijacking there. It works pretty well because it's unprotected. The majority of what you do built into Metasploit with all the exploits that are there are buffer overflows. I would like you to look at buffer overflows, the section of this particular video. Remember, this is in system hacking. I'd like you to look at the buffer overflows. It's about 17 minutes in, I think is where it is, but I don't want to discuss it in class today because I don't want to consume all of our time for that. And in fact, what I'll do is I'll give you, there's the link. Go about 15 minutes into that video, and then it'll land right here and then go, hi, and then I'll have my different shirt on, okay? So I don't want to cover that here in class. I talk about buffer overflows from a very end user standpoint. There are much better, much more technical details about how buffer overflows work, but I will tell you, I've learned those techniques and they don't do us any good for the exam and for most of what we're doing when we're using Metasploit. If you're doing custom exploits, then you have to really understand how buffer overflows are built. If you're doing reverse engineering malware or you're building malware, you need to know how buffer overflows are built, but that's way beyond the scope here. If you're doing any kind of application penetration testing where you get an executable locally and you do a decompile, becomes very important, and my explanation isn't going to do you any good. Okay. If you look in Metasploit, it's great at exploiting OS programs that have buffer overflows in them for the operating system. Most of the time when we talk about buffer overflows, what we want to be able to do is to execute arbitrary commands that are under our control, that are running at the system or root level. Now, the best arbitrary command really is make me root or make me system. That's kind of the point. But normally what happens is you get this low level process down here, and then you have to escalate your privileges up. That's what the advanced Metasploit labs are about. When you go to the second or the third PDF that's in that list, they show you that walking process. That can take 40 to 50 minutes to do that lab that's preset. For anybody who's doing the practical CEH, the master CEH, I told you that you have to get the iLabs and do the iLabs. The iLab on buffer overflows, I did it 3 times, and the fastest that I could go was 90 minutes. So expect when you get to the buffer overflows or section 6 system hijacking, and they do buffer overflows, expect to spend at least 2 hours on that one lab. It's pretty brutal. And I would suggest that you do it 2 or 3 times. Okay, executing applications. Now we're on the system. Remember, users and admins or maybe UAC can install those programs. And so what we want to do is we want to put in keyloggers. Remember, we probably could, through a USB drive, convince somebody to plug this thing in. I give you a list of all the different keyboard keyloggers that are out there. This is, let's make sure that it pops up. This is really what you want. You want a keyboard. You can just walk up to somebody and say, hey, look, I know that your keyboard's really dirty right now. We're coming in and we're doing a cleaning process on keyboards, especially because of COVID. You know, hey, let's go ahead and take your keyboard away. We'll give you this keyboard as a replacement while we clean it. We're going to go ahead and do our 10-point cleaning process. It's a white glove service, blah, 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 blah. You take this away for a moment in time, you plug this one in, or you can say, you know what? Why don't I just do this in front of you so you can see me doing this keyboard cleaning process right here. So it's not like I'm going to go ahead and mess with your keyboard or anything. I'm not messing with this keyboard. I'm messing with that keyboard right there. I've already messed with it. I've already given you this keyboard. Go ahead and log in. It's going to take me a little while to do this. I clean their keyboard. I give it back to them. I unplug this keyboard. I take it with me, and it's got all the key logging information on it. So this is the way to go, without a doubt. USB drives always get detected. I like this feature set that's here. These are not cheap. I think this one's, yeah. Let's see. Forensic keyboard keylogger keyboard. This one is, yeah, so they're anywhere from 69 euros up to 102 euros. There are all sorts of other ones that are out there. Forensic keyboard Wi-Fi, you can use the Wi-Fi. It works really well out there. They talk about the different types of keyboards that are out there, the Dell, the HP, the Logitech. Those are great. What you don't see in here, I don't think, they don't have them here, is you can't get the Macintosh. These are really thin keyboards. You can't get the Macintosh yet. I think there's a couple people out there that have them. So that's your keyword. That's where you want to do. You don't want to do software keyloggers if you don't have to. That maybe you can't get physical access to it. Okay, fine. Then you have to do software. On the software side, it's better to capture it at the form grabbing and at the application level. For spyware, what is spyware is the big problem that we run into right now, but it's just programming programs that record users' interactions without their knowledge. Cisco says that the majority of spyware that is out there is less than a keylogger, but more than you actually want it to do. Ultimately, what we want to install is rootkits. They will replace operating system calls and lie to the end user, granting full access. And the way it works is it uses this thing called system hooking, where we actually look for you to make that DLL call. Well, not you, but the application like Word, PowerPoint, Excel. And when it goes to do that, we capture that communication for that moment in time and say, oh, you're looking for blah, 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 blah. We're going to intercept that command, get this information back for you, and we may even pass it on to the original DLL, but we're going to capture information about session state right here and right now. Anything that we return from that particular DLL, let's say that you were doing a directory listing on that machine, The rootkit will lie to you and say, I'll tell you the directory listing for everything except for the files that matter to me because I don't want you to find me out. And so that's what's going on there. Okay, now we want to get this data out the door. In exfiltration, video cameras, data, all this stuff that's on there, we want to pull this stuff out. We can even pull it when it's sitting in separate locations that are trusted locations. We steal this stuff. And the way that we do that is we usually steal it through covert channels, transferring it over command and control channels. But remember, they have limits. The best command and control channel that I like to use that is relatively unprotected throughout history is the Internet Printing Protocol, the IPP, and the storage on my printers. I really like that as a place to go. I don't get to talk about that in this class. It's not proprietary. It just takes a lot of work to get it done. It is about you have to have a printer, an HP printer, older printer. You have to have a printer set up on your network, so it really doesn't do any good for me to test it here. Well, in Dean's perfect world, I would really like to set up my HP printer here outside of my firewall and let you, I'll put stuff on it for you to pull down, but we can't do that. We might interfere with each other. Okay, the techniques. Now, the way that we hide data most of the time that you care about from an exam standpoint is either going to be in NTFS alternate data streams. That's the Windows filing system, and looking at the alternate data streams that are there. There's a very technical explanation that's there, but it's a lot easier to think about this. If I were to go to a file, and let's say I were to say, I'm going to choose a file on my, I'm going to go into my filer right here, and this is going to be a little tough to see for a second. So I'm going to pick up my file right here, and I'm going to say, show me the properties, and in Macintosh, that's get info. And then when we look at all the information that's sitting right here, the name, okay, well, that's going to be stationary. The comments, this is super secret data. Now, when I look at that, I know that's a problem for you to see, okay? That super secret data is inside of there. How big is that file? Well, if you were paying attention, get info. In this case, it says it's changed its file size to 268K because I put this garbage inside of there. The reality is that there are a lot of ways that you can hide metadata kind of like this and hook it onto the end of the file so that the file size does not change. In this case, it does change because this isn't really NTFS data streams because this is a Macintosh machine. But if you were to look at that file and choose the properties of it, the file size itself does not change as we're going along through this. You could mess with the metadata if you wanted to, but normally what we're doing is we're doing this thing called forking, and that's just joining one file to another, copying that file out. The actual file bits that are being copied is larger now, but if we look at that from a file size calculation standpoint, nobody's looking at the file size as it being copied off of that network. It needs to be a relatively reasonable size file. So if you've got a PowerPoint file that's, that's 5 megs, you can add an additional 5 megs worth of data to it. If it's 5 gigs, then you can add more file size to it, but people are going to go, why is this file so big if you did it disproportionately? For steganography, think of this like secret messages where we do invisible ink, okay? When I transmit that file to you, or not necessarily the file, when I transmit that piece of paper to you, everybody looking at this piece of paper between us, if I say, here, Heidi, take this piece of paper, and I've written in invisible ink on this, somebody will grab that and say, hey, let me take a look at this. Oh, that looks normal. Okay. And so hands it off to Heidi, and Heidi, you can go ahead and take this home. And she steams it under the kettle, and she sees the super secret is, she's found it. So we're transmitting over a normal channel. We're extracting the destination data, and that maintains the confidentiality between us. That's just like invisible ink. But if you pick that file off from me and you go, I'm going to run this under a steamer, if I wrote it in plain text, you would see exactly what the message is. And you would know that this was coming from me going to Heidi, and now you would know the super secret. So maybe what I do is I write it encrypted, and then so even if you do pick it up, you know that she and I communicated, but you don't know what we said. Steganography is communicating in the presence of adversaries without their ability to understand the channel that we are using. That's really what it comes down to. Covering your tracks, it's going to be manipulating the logs, disabling auditing, and wiping the disk. Today, modern ransomware does that very thing to us in a multitude of ways. From a testing standpoint, we're almost finished here in this section. If you're going to build a professional practice in this, this is 20 to 40% of your time. It could be on devices that really don't count toward your goal, non-specific devices like modern applications or any kind of mobile device that's out there that you've attacked so that you can get access to that next one in the list. These are ancillary victims in the scope. They really don't count, but they're your only way through. You need a way to hook around that. Your tool is going to be Metasploit. I use, in my professional practice, I use the standard Metasploit. I don't use the Pro license. What's nice about the Pro license is you've got multiple, a large team can transmit data back and forth and capture information that they can use to produce reports. And the workflow is really elegant. But since most of the time I'm working with disconnected partners on this, where I do all my work, I package it all up and I send it to them, and then they take action on it from there. I really don't need the Pro license. The artifacts are probably going to be screenshots. It might be a capture the flag scope objective. Find me the super secret version of this next software that we're deploying out there. So it'll be something like find this file. In October, when we do our capture the flag, I'm going to ask you to find as many as 20 to 30 flags over the course of 4 hours. So you'll have to know your tools, know how to work with your tools. What Metasploit said, well, what H.D. Moore said in his philosophy on Metasploit that irritates defenders is, if I can find this vulnerability in 2 separate places on the internet, then I'm going to weaponize it against your machines. You should patch your machines. And everybody's, well, that's not fair. It's like, so what? Bad guys are bad guys. They don't play fair. Now, from a controls standpoint, timeout. If you see the blue here, I do not believe that these are the good controls for Metasploit. However, for your exam, they will say a good way to protect against system hacking is to which of the following things and which order. It's not part of this course. They ask you that, and it gives you, I've broken this down into a set of what would you do for passwords, rootkits, spywares, key logging, and privilege escalation. What would EC Council want you to say? These tools very rarely work today, but you're giving advice from an exam standpoint. So they have to be very generic about this. These usually fit under the heading of best practices. Okay. We are at 3:20. We have 40 minutes left in this session. I've talked about the Metasploit lab and how to set that up. That is a link to that lab. Does anybody know what the Metasploit help option is? This is a trick. what is the Metasploit help option? If I type in M, can't spell today. If I type in MSF console, what would be my help? I type that into the attendee chat. What would be my help? That's okay. It's good that you have no clue because you haven't practiced with it. Man Metasploit, I don't think that that one will work. Okay, let's try. Now remember, I'm already inside of Metasploit. You can see down there at the bottom, it says MSF6. So you want me to type in man here, right? And it goes, no, doesn't work for me. Anybody else? This is going to kill you. We're inside of the Metasploit framework, so we need help there. Now, it is very important. If you forget everything else about the help that you need to be able to understand how set host, remote host, and local host works. In the lab that I give you, I go over each one of these details. But see, now what I've done is I've typed help inside of here, so it gave me the generic help. There is help in every single different component inside of here. And so this is help while you're inside of the framework itself. On the outside, it doesn't really work. It was a trick question. Thank you for playing along. I appreciate that. Okay. Show options would give me a context-sensitive menu that is better than help, because it would show me options where I am. Because if you dig down in, like if you go to the auxiliaries or the interpreter or something like that, those other sub-levels inside of there, show options is actually a better thing because it shows me options at this point. So that's good. Where are you in the hacking process? This one should pop right out at you. Give me the EC Council words for this. As soon as we're finished this section, we are going to take a break. It'll be our last break of the day. Okay, very good. We are in exploitation. Somebody come up with pwning. I like that. Yeah, that's a password owning. That's what we're trying to do at that point, but we're trying to compromise the machine. I like the sentiment there, but the official EC Council term is exploitation. Okay. Oh, sorry. Here's our 2 quiz questions. This one, if you don't get this one, beatings will be issued. Which of the following is considered an exploit framework and has the ability to perform automated attacks on services, ports, and applications? You got 4 choices there. If you pick any one but the right answer, I'm coming to your house. I didn't think you got. Somebody always tries to be a smart aleck and goes ahead and chooses something else. It's Metasploit. See, if you hadn't come, look at all the wording around that, performing automated attack services, ports, and applications. There's a lot going on in that question. And if you've been here for 15 minutes, you know what Metasploit does, and you're great. Okay, let's try something just a little harder. Which one of the following tools the hacker probably used to inject HTML code? Sorry, my wording's off there because I don't have a lot of space in that wording. Inject HTML code. Okay. So this brings up a couple of questions that you're going to that are going to happen on your exam. If you watch every one of my videos, you don't have to watch the lab videos for CEH, but if you watch every single one of my videos, you will cover all of the tools that are on the exam. In other words, you'll know their names, and you have to build note cards and you have to do labs on them. If you have looked at every one of the mind maps that are on tools and looked at the green section, you'll have a list of all the tools that you have to know for your exam. You're going to run into tools that you haven't seen. You're going to run into probably 4 or 5 tools that you haven't seen, but all of the other tools you have. And so now this is kind of an inversion kind of question. Now, we haven't talked about EtherCap, but we have talked about Wireshark and T-Shark or TCP dump. We've talked about those two. So which of the following are would a hacker use to inject HTML code? You know that Wireshark and TCP dump, by their very names, they're listening tools, right? So you know that they don't do any kind of injection. Now, if you would have seen in other sections, the tool section for a Wireshark, for Wireshark, we would have talked about EtherCap in that tools section. So you would have known that that one is only good for layer 2 hijacking. You go, I've never heard of Zap before. But you know that this is a layer 2 tool, and those two don't do any kind of injection whatsoever. And so you can do that through process of elimination. But that means that you really have to know your tools. And what I tell people to do for every one of the tools that's listed in the green section of each one of the tools mind maps, that you have at least one note card on it. For Metasploit, Nmap, any of the tools that I've said 2 hours worth of time on, think of like 4 to 5 note cards on it. But I talk about the note carding process for your tools. It's a very separate process within the note carding process in the videos that you can watch there. But if you do that and you create those note cards for each one of those, you won't get stumped by Zap. It just won't. All right. Now that brings us to our last break of the day. We're going to take 5 minutes, and when we come back, we're going to talk about hijacking. Hijacking is very easy to say. It's very easy to describe. It is difficult to do. We will not do hijacking in this course because it's beyond the scope of the exam. With that, 5 minutes, run away, go play. This is your last break. All right, we're going to talk about hijacking here. This will be the last thing before we break for the day. I'm going to hand it back over to Heidi, probably with about 1 or 2 minutes left so that she can get us out of here on time. So when we talk about hijacking, we really should look at the mind map and understand what's going on here. In session hijacking, from a conceptual standpoint, we don't have to attack the servers directly and defend, okay? So we can go to the other side of this connection here, and that's really what we're trying to do. But the key to this is understanding session and what's called state data. So we're looking for the trusted identifiers that are being sent between client and server. That could be a session ID, it could be a resource ID, it could be a cookie, any one of those things. And then what we do is we pick up that piece of information that's supposed to be a crappy substitute for a password, and then we replay that. And so if we can do this properly and we can deal with the layering situation that we have here, that will allow us to gain privilege of the previous connection that's out there. Okay, now we have to think about why this works. It's important to understand why it works, because then once you understand why it works, you'll be able to recognize this pattern that happens in the future with a man-in-the-middle attack or a hijacking attack that otherwise wouldn't be, because there's always new protocols being rolled out all the time. Since I've been doing this in my short career of penetration testing, I've probably been doing penetration testing for about 10 years. And I don't do it all the time. I'll do a lot one year, and then the next year I won't do any. It depends on my projects, depends on who comes and asks me to do it. But over that 10 years, I've seen many different hijacking attacks that have worked because new protocols, new things crop up. Now we're using Slack to do lots and lots of communication. 10 years ago, there was no such thing as, well, maybe there was something that's called Slack, but it wasn't in its present form that we're using it. Why does this work? It works because of the whole concept of layer abstraction. So let's think about the connections. We have a victim client and a victim server. They're connecting back and forth, and we're the evildoers. So when we start with the victim client, on their side of things, they're setting up a layer 3, layer 4 communication. That's what they're going to do. And they're going to go to layer 5. Make sense? So on the client side of things, what we see is an IP address and a port. Up above the IP address and port is the session information that goes back and forth between the two of them to create synchronization at layer 5. I know that SYN and ACK are part of the TCP protocol, but that is session keeping that is up at layer 5, okay? So now we look at it on the server side of things. It has an IP address and a port, and it does SYN ACK. You'll notice that the pound sign is different here. So if I, as an attacker, with a completely separate IP address and a completely separate port, it helps if they're close, but they don't have to be. If I can predict that sequence acknowledgement function at layer 5, I don't have to change my IP address in my port. I can intercept. It's easier to intercept on the client side, but you could, in theory, intercept on the server side. That's when we do it on the server side and we play the server role. Now what we're doing is we're doing man-in-the-middle attacks. So the layering abstraction separates the IP address and port from the session sequence number. What I do as the attacker is I replace the victim's IP address. So if you were talking to Heidi, you're the client, she's the server, I don't try to change and convince Heidi that I'm important and it's a different IP address. her upper layer application is not even looking at my IP address. It's looking at sequence numbers. And so what I do is I usually keep that victim's port session. So I won't have the same IP address as you, I'll have a different IP address as you, but I'll use the same port and the same session sequence number and keep on passing that. And so what happens is I bump you out of the way and Heidi and I continue on with the conversation. Now, what I have done at this point is I have hijacked your valid session. Where was the username and password in this? That stuff happened a long time ago and I don't even care about it. I'm not even looking at that stuff. And Heidi's not looking at it either. We've gone beyond that. We're into this conversation that we're having, this really close, intimate conversation. And I just bump you out of the way and she's not paying attention to that it's not you anymore. She's not looking at me because she's gone ahead and said, well, this will all be taken care of by an upper layer conversation. And by the way, I don't know if you've ever seen this, but there are magicians that do this trick where they distract, they'll be talking to a person. I've seen this, you can look on YouTube. They'll be talking to a person and what they'll do is they'll distract them and they'll say, look over there. And the person turns away. And what happens is that person steps out, a new person steps into the exact same thing. They've never seen this person before. And they step into the role and the other person runs away real quick. And they say, okay, now come back here and look at this. And they keep on having the conversation with them. And the person that they're talking to doesn't even realize that it's a new person about 8 times out of 10. And in one case, they even like switched genders and the person still kept on talking to them. So the attacker and the server keep going and the server doesn't recognize that it's different. The victim is now cut out of the communication. I have successfully hijacked the session with the server. There are a couple of other things that we can do. What I could do is I could say, you know what? Because I want to see what's going on between the two of them, and because neither side can actually see me because it's not a person at this point, it's a network connection, I can go ahead and say, I'll keep the communication going with you and I'll keep the communication going with Heidi. I'll stand in between the two of them and keep the session going. That is a man-in-the-middle attack. Again, sorry, ladies. Okay, this is inside of exploitation. This is a specific type of exploitation to compromise the client-server activity. It allows us to gain access without having to worry about all that password stuff. And that's all gone out of the way. Is it privilege escalation? Well, yes, it is, but it's privilege escalation and gaining access all in the same thing because we're abusing the layering abstraction concept. So to be clear about this, session hijacking, I take over the valid communication session. It can be between any layers, but it must be between layers. We must have a layer protocol and another layer protocol, and my ability for the server or the client to not pay attention to the fact that the lower level has been replaced in that case. The reason why this works also is because the authentication mechanism is taken care of at the beginning of the session and is not used. We use this replacement token, or even in the case of SYN and ACK, we use that session setup between the two of them. And I'm able to manipulate that active session. Now that's session hijacking. Spoofing doesn't take over the existing active session. Now the beauty in this is session hijacking takes a lot of timing. Heidi has to be willing to take on a long pause. I have to be willing to go ahead and be very quick about this. And you have to be very willing to take on a long pause. Okay. Just came across anything in the middle now, Microsoft documentation, adversary in the middle. Yeah, AD, and here's the thing is, adversary in the middle doesn't have the same sound, the onomatopoeia to it, and that's why it's man in the middle. So adversary in the middle, person in the middle, man in the middle, agnostic thing in the middle. so yeah, they're all the same thing. With spoofing, as opposed to session hijacking, I like to use session hijacking and spoofing because then we don't have to worry about the man in the middle kind of stuff. In spoofing, what happens is you and Heidi are talking, and I watch the conversation go, and you go, yeah, I'm done. Now, what happens is, a lot of times, have you ever gone to a shopping cart where you're finished shopping and you click finish shopping and you don't click log out, but you close the browser window? That, if you go back in and go, oh, I forgot something, I need to go ahead and buy another thing, and you open up another browser window with that browser and you go back to that shopping cart, it'll go, you were just here. What did you forget? And it'll keep on going with the session. It doesn't close that session out right away. So what happens is I can pretend to be another user or the machine to gain access at this point, and I can go back to that session that has not expired. What I'm doing is I'm reusing the authentication of that session that was originally there, and I'm using a new session with the stolen credentials. But these stolen credentials aren't username and password at this point. It's like some sort of session variable or cookie or token ID or session ID that's out there. That's all it really is. I'm not really doing full authentication. And by the way, the control for this that Defender's put in place is re-authentication on a regular basis throughout the session. But end users won't tolerate re-authenticating in the middle of the session to protect them. What's beautiful about spoofing from an attacker standpoint is much less synchronous activity, and I usually won't be caught by the intrusion detection system because the application on the other side is kind of weak. From a protocol standpoint, a lot of people will start saying, oh, well, that's bad session management for TCP/IP sessions. And they'll start blaming the protocol. And it's not a weakness in the protocol. It's a weakness between the protocols. And if you keep that uppermost in your mind, then when the next opportunity for session hijacking, because somebody has a different application that does it between different layers, once that occurs again, you'll be able to take advantage of it very quickly. Because it's not a very technical attack. It's not like it requires a buffer overflow or any kind of reverse engineering malware or any of those kinds of, it doesn't require any of those things. It just requires us to be present, to work with replay technologies. Usually you can do these with, there are many different packet capturing tools, Wireshark. We can go ahead and pull the packet off, and through a little bit of programming or replay tools that are out there, we can jump into that session. We don't have to be really talented in this case. We just have to know how Wireshark works. We have to know how a session works. We have to know how to capture that session and then jump in there. Okay, what do the techniques look like? There's two. We're going to talk about one today and a little bit more about the other one tomorrow. For network hijacking, this is between client and server. We're looking for session hijacking, and it happens in 3 phases. The 3 phases are tracking, desynchronization, and injecting. For tracking the connection, I'll use a sniffer, and what I'll do is I'll look for a sequence number. Now, I'm using this as an example. The TCP sequence number is at layer 5. TCP as a protocol with the port is at layer 4. If the application, client-server application up at layer 5 is very predictable, if they don't start off with a random number and they don't advance that random number in a little bit of random way, and I can predict that based upon that application that's going on. I'm not attacking the application, but I'm looking at the sequence number that is implied down below that. Then what I do is I find out that it's there, and then I desynchronize. And what I do is I go into the connection between the target, between the victim, between the client and the server, know that the session has been established. for a moment in time, there's no data being transmitted. Let me go get my credit card. It's a classic example of buying on a site where you've gotten all the way to this other place and that person goes away from the session. They're in the middle of buying and they go make another decision. Credit card data is already loaded. They're ready to go ahead and pay. And so what I'm looking for is when the server sequence number is not equal to the client's acknowledgement number. I'm looking for that place inside of there. And then I interrupt that connection between the server and the client. So I'm desynchronizing between the two of them. Then what I start doing is I start injecting my own packets. That's the active participation pass of this, where I'm passing between the client and the server. Now, I could read the stuff coming back from the client, inject more data into that. So what I could do is I could say, oh, you want to buy 3 of this thing, and change that 3 to a 5 and send it on along the way. When it comes to shipping, oh, where are we going to ship that? 2 of those come to me, 3 of those go to them over there. That would be really hard to do, but you get the idea is that I could siphon off if I wanted to. At the application layer, usually this is some sort of session ID. We're looking for cookies. We're looking for bad, unencrypted cookies. And you go, well, Dean, this would never happen anymore because application layer of attacks have been taken care of. The place that we're going today, there's a woman, her name is Sunny Ware, API security. She's a friend of mine. Sunny does application API security. Everything has an API on it these days. Everybody's coming up with their new application programming interfaces, and they're not implementing sessions correctly. If they would just follow Sunny's advice, everything would be okay. But they're making up their own custom APIs. As soon as you hear that, you go in your head, this is going to be susceptible. Okay. By the way, she does a class every once in a while for O'Reilly. I haven't seen her do one in the last 6 months, but she does them. Remember, what a cookie is its state. You could call that a token if you wanted to, but really what it boils down to is it's some sort of crappy authentication replacement. If the cookie is used beyond the session of the victim. So if I can pick up that cookie, reuse that cookie with or without man in the middle at the same time or after the victim session, it doesn't matter. So if I can pick up that thing and it's actively gone, that's why the end user training is always log out when you walk away from a session. Don't just close the tab or don't just close the window, always log out, because the session will be held open and somebody can attack you at that point. That's why the suggestion is there. So how can I go after this session token? Well, I can do sniffing, man in the middle, session replay, predictable sessions, and session fixation. I can force the session to be something. Normally, this is done on the client side of things with things like cross-site scripting, cross-site request forgery, or woman in the browser. I could, and we do this a lot with applications, do proxy attacks. And this is redirecting the end user to some other section of the site. This works really well when I can falsely resolve Amazon.com for you to my IP address, and you come to my site and I've got it completely set up to look like Amazon. Actually, what I'm doing is I'm passing their stuff through to you. It works really well to forge those legitimate requests by coming to me. That proxy attack can be done at the DNS level because I am Google spelled with 2 zeros rather than 2 O's, and that your DNS cache, you've got it in your cache over on your side, or I just falsely resolve DNS for you. And now as an attacker, I am present for the entire session. That's very easy to say. It's difficult to do. You have to wait for your opportunities. They aren't always there when it comes to this. A lot of the applications have been protected due to OWASP. developers are working well to go ahead and take care of that at the application layer, but it's not working well at API levels, and custom APIs are proliferating today. The tool that we would use to do network session attacks is EtherCap. Okay, so this is a live testing. In live testing, we would do red team, blue team. Usually you would see this happening. If there's a defender defending, that's when we use this kind of tool. EtherCap is very noisy. You need to be ready, especially if you're going to do it on the client side. You should not. You should be saying, hey, let's stand up that fake client out there. Have a great legal team and make sure you put good documentation out there. Here's the key to this. In theory, when I'm attacking you, somebody from the outside may be watching. So if I'm a good guy supposed to be doing penetration testing against Heidi, you could be sitting out there watching what's going on, and you, while I'm doing my communication, you could take over my session. And that's what attackers will do, and quite often. The control here is encryption, but it doesn't always work, especially if you can create a proxy. At the application level, when we look at any kind of session variables, they need to be random and short-lived. The way that you can do this with your protocols, and defenders do this more often today, is HSTS, but it is difficult to implement. Now that brings us to the end of this session. I've got just one more minute here before I turn it back over to Heidi. I wanted to talk to you about what you should be doing to prepare for our next day together. If you sign up, I will take, oh, sorry, that's application buffer overflows. That's the wrong one. Let me give you this. I would like it if you signed up for the quizzer beforehand, and so that I can do the quizzer tour. I would like you to look at the mind maps for section 13, 14, and 15 that we will be covering on the last day. I'll do a lot of demonstrations on that day. It will be a very different day for us. When this session is over, I have it on my list for everybody that's having a problem with their lab. Send me an email that says, need help with my lab. Send me that email right away, and then I'm going to go take a break for about 20 minutes, and I'm going to come back. I'm going to fix it. I'm going to test it, and then I'm going to send you a message that says the lab is working. Were the AWS images fixed yet? No, because I've been in class AD, so I'm going to fix it and test it after class today. So thank you. And with that, I'll turn it back over to the excellent Heidi.
Awesome, Dean. Thank you so much. And thank you everybody for joining us today. Just a reminder, this class was recorded and you can access the recording within 48 hours on the same page where you joined us for class today. Also, please join us for tomorrow. It will be our last class in this session, day 4, same time, same place. Thank you so much, everybody. Have a great day. Goodbye.